Hi all, do we have viewers? We have one viewer and one like already. Rayuga. Is that Beyblade Rayuga? Rayuga overpowered. Meteor El Drago. Or El Drago. Finally, Kenta got everything right. That should not have happened, maybe. We have only one viewer. I need at least 5 to start. It's Ryuga. Oh, really? Nice. But where are other people? We need viewers. Let me text on group maybe. Mm, guys, this stream is more important than the previous streams because most of you people think you can solve these ratings, right? Like from 1900 to 26 or 27. You people think you cannot solve these ratings, right? So you guys can know here exactly how difficult these are, or why you cannot solve, or if your assumptions are true or not, at least. I will start again. Like I will again introduce myself, not myself. I will again introduce about the stream when we have like 5 viewers. We need viewers. Where are other people? Let me see. You can hear me, right, Ryuga? I'll see if it looks better with light on or off. Is this better or is this better? Oh, that's same. We need 5 viewers to start. At least 5. Who all are there? Where are there? There are okay. We have 5 viewers. Okay. We have more 5. I think yeah, 5 is fine. Uh, yeah. So I'm again starting my introduction of the video. This stream is more important because it's a newbie level must watch stream. Now that's just not the reason. Here I will be trying to solve from 1900 to as long as we can go today. And it is more helpful because you guys will already have some assumptions, like you cannot solve 2400s or 2500s, or some people might have told you sometime that you should have gone slower, that first you should solve these things. All of those things are not real. I think things are not real because you guys can see today, like I may also struggle a bit in these ratings, right? So it's even I can even give more good explanations, or like how we can drift away from the right direction and then may again come back. We can just see. I think this is more interesting one. Don't think I rated for you and not watch, because you can learn more from this, is what I'm trying to say. I'm tired already. I cannot give more introduction. So yeah. Oh, let me share my screen. Oh, I'm already sharing it. Okay. So these were the previous problems of this series. Uh, Probably this is like 900 rating problem, if I remember. Check out my old streams too of this series. Like the video, guys. Like, what are you doing? 7 people are there and there are only two likes. Are you guys like this inactive? Should be active. So yeah, for people again, I'll be trying to solve uh, 1900 to as long as we can go, and I'll try to explain them well, and you guys can try to understand if 1900 or if 2400 are actually as difficult, or in the way, in the same way you think they are difficult or not. So let's just keep 1900 to 1900. So we have done till 1800 in last time. I have skipped 2 problems, one at 1400 and one at 1800. But then yeah, so should I go for this? It seems a bit nice. Control tower or goblin. Oh my god, graphics also sounding good. I should open something. Say, does anyone want? Is there any preference, or? Hmm, I'll go for D. Let's see, because some of you may be scared about D, right? D problems, and then there are D or D or D. See, sounds even scary. So let's try to see this. Of course, a undirected graph. Half of you will piss your pants right here. That's why you guys can solve a bit difficult problems. Graph's nothing. It's just vertices and then some edges. See, n vertices and m edges. The graph contains no self loops or multiple edges. You are also given a multiset here consisting of L elements. Starting from vertex 1, let's read the problem, because reading the problem without getting scared is like 50% of the solution, really. And if you actually understand the problem well, problem is half solved. All you have to do is some more work. So reading problem, you guys should force yourself to read in a way where you don't get scared of the problem, where you don't make assumptions, but then read it whole and don't stop in between too, like I'm doing now. Starting from vertex 1, you may perform the following move any number of times as long as the multiset A is not empty. You can do any number of times as long as it's not empty. It seems select an element K belongs to A and remove it from the multiset. So we have a multiset, we are removing it one. Starting from vertex 1, I don't know how we will use vertex. You must remove exactly one occurrence of K from A. So we will remove only one occurrence because it's a multi-K. Traverse any walk of K just to reach some vertex, possibly the same one you started from. So yeah, we are at vertex 1 it seems. So we have a multi-set, we remove one and then we try to move a walk. A walk in the sense, see, they give definitions of walk because the problems are so good that you don't need any external topics or external things. They are even giving the definition of walk, means everything you need is right here. You should just apply logic and solve the problem with a bit optimism, I guess. So you guys understood the operation, right? You're at vertex 1, remove one, and then you have to do that many edges. You have to pass through that many edges. So walk of length K is a sequence of K plus 1 vertices where adjacent things have an edge in the graph. They may repeat. A path is probably a walk with distinct vertices, I guess, or a simple path. Uh, so now let's read the problem again, because until we don't know the exact problem, we cannot underestimate or we cannot estimate its difficulty. And I will give you guys a tip. In contests, you should underestimate problems. That helps you a lot. In contest, you should always try to underestimate a problem. That's the best thing you can do in the contest. For each I, determine whether there exists a sequence of such moves that starts at vertex 1. So for each I, we should and end set vertex I using original multi-set. Should we use all of them? Now, we can use any number of times. We need not use all of them. So we have to see for each vertex I, we should be able to say if there is a way, if there exists a sequence of removing things so that you can start and then end up at I. So problem seems a bit complete, at least. Like we have to find it for all vertices. It seems. Note that the check for each vertex I is independent. You should restart from vertex 1 and use the original multiset for each case. So you guys have the problem right now. We have a graph, we have a set, and it's like you take few things from that set and can you reach this vertex using this set. So it's like a bit good problem. You can try to work on it a bit and then see what's the difficulty here. See, when you guys, if you are going to get scared of this problem, there are so many things you can do. What if the multiset has only ones instead of 1 to 10 power 4? What is the answer then? How can I solve that problem? Or maybe some other constraint, maybe trying to see the line graph, maybe what if it is a tree? You can do all these things in the contest or while you're trying the problem. But then what you guys will do is like just read the problem, not 4Ds. I cannot solve the fourth problem and then leave it. So we'll try to solve this a bit. I will just once again check if we have viewers or not, because we have DDD here. So DDD. Please try to do a sleep coast. No, bro, I will maybe I'll try it in between, but this stream, as you can read the title, is meant for. I have my internet, right? Yeah. Is anyone following the question? Try to solve the problem. Like try to maybe use pen and paper and try to think about the problem parallelly, right? Because we are going to solve a bit more difficult problems too. So try to think about the problem. You guys can think about the problem, because the problem as it sounds complex, right? Because we can remove any subset, and then if you remove any subset, and then it's like the subsets. See, the problem. So to reach I from 1, we choose some subset, the order, because if there is a path of total length this much, you're reordering, you can again still do the same thing. S of A, if there is a subset such that, let's say this subset length be sum of the subset, we should determine if there's a walk from 1 to I of length sum of S. So this is obvious, right? Because your goal is to go from 1 to I. So this makes it a bit simpler. Even though it sounds like we have to take one and then another one and then another one, then is it possible is what they are asking. But then it's just asking like only the subset sum matters, right? Like if you can get a sub, let's, so yeah, that's it. We have to find for all vertices. So if you guys thinking that there can be great logic in this problem, we are finding it for every vertex. If you are finding it for every vertex, that shouldn't be that difficult, right? Because there is a simple code that finds the answer for every vertex. Yeah, so let's see again. Slowly, guys. So parity, yeah, we can keep going back and forth, right? All that depends is parity. Uh, but yeah, BFS and parity makes sense. But why are you giving me solutions? I have to try them. I have to try them, and then mm, I have to try them, and I have to uh, show my approach. So yeah, few things we can use, because why would BFS makes a bit sense? Not even BFS, just so that means there is a walk. There is a walk from 1 to I of lengths of sum of S, right? So let's take sum of A, the maximum sum we have, okay? Because you cannot do more than this using everything. You can only go this much distance. So next time, be careful in giving me solutions, okay? Yeah, but still BFS, see, it's not about using BFS or anything. It's a bit logic here. Like we can only do this long sum of A. So can you reach vertices that are farther from sum of A? Now you cannot reach them, right? So let's say you're trying to use sum of A, okay? With this, let's say you're trying to use everything. With this, you can reach all vertices. So let's look at BFS tree itself, okay? Let's look at uh, should I explain BFS tree's theory that I know, like a little bit of theory that all non-edges? I will do that in a video. BFS tree, small theory is there for BFS tree and DFS tree. Very small theory, like that BFS tree non-tree edges will be on among adjacent layers, and on DFS tree non-tree edges will lie on vertex to ancestor. We can explain it later. So if you look at BFS tree layers, layer sum of A, which is layers greater than sum of A, can be reached, right? They can be reached. Layers equals to sum of A, they can be reached. Layers below sum of A, but same parity as sum of A, can be reached, because you just come back two times, right? See, try to go there and then come, because let's say it is sum of A minus 2. Go to sum of A minus 2 in the BFS tree, come back and then come again, come back and then come again. You can keep doing that. So all of the things which are less with the same parity can be reached. So now the remaining things are with different parity. Can this be reached? This is the only complexity here. Only these are the left out things, because most of these things cannot be reached, because the best you can move is this much, and these things can be reached. well, because you will just use them, just go down, 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 down in the BFS tree, and then you reach them at that level. Okay, but just think about it. What topic will help you solve? You don't say, but in general, there is a conception that DP or graphs are difficult problems, right? Where did that came from? This is a graph problem now. The maximum walk we can go, and this many number of times. So everything minus 2, minus 4, minus 8, all of them also minus 6, minus 8, all of them also can be visited if you can visit this. So like simple tries, right? It's logic. It's not like you get scared of a graph problem, or you have to learn BFS tree to do this. Like you can just say minimum distance instead of BFS tree too. Okay, minimum distance itself to reach that is greater than this, then you cannot reach that using sum of a length walk, right? It's obvious, it's simple logic. Like if you can only travel this much distance, and then if it is so far away, the minimum distance to reach itself is so far away, you cannot reach it. All of those are simple. Like it's not topics, it's logic, which you guys are bad at using. I'm just joking. You guys can hear me, right? So this is the only problem for us, right? So now, as you guys can see, if all here now that matters is, as you have seen above, what's the farthest? Let's call sum of A's parity as good parity, and the remaining will be bad parity. Parity vertex you can reach using using S from A. So this is the question that's needed, because if you can reach one vertex in this parity, so we have BFS layers again. If you can reach the farthest one, you can reach everything that's closer to that too, right? If you can somehow make that much distance to reach this thing, if you can somehow take some elements from this set and reach this one, you can do minus 2, minus 2, minus 2, and you can reach all of those things again using the same subset. Yes, using the same subset S, you can reach everything smaller. So again, it's like the same logic. That's the only logic involved here, that if you can reach this in BFS, if you can reach the farthest even one, you can reach everything less than that. If you can, in odd parity now, if you can reach the farthest odd one, you can reach everything less than that in this parity. So now this problem is a bit, I'm solving it. So this problem doesn't seem too weird or too complex, right? Anyone that's scared of 1900 problems, you have to think why you cannot even try, why you cannot even put some effort in solving that. Did you solve it in contest, Lokesh? Damn, we have 4 viewers now. Nice. See, fuck. After reading editorial, I don't read editorial. You can read if you want to. Is that the reason? We need viewers. But I have solved it. At least just using your hint that BFS plus parity, I have solved it, I guess, right? I mean, that makes sense. Like we just have to find this thing. So now what, how can you find this? So sum of A, parity, B, whatever, but good. What's the sum? You sum of S with different, what's the maximum sum of S with different parity that can be formed? You just remove minimum odd number from sum of S, because if you remove an even sum or some even numbers, it doesn't change parity. You cannot get a different parity sum. So what's the maximum sum of S you can attain that has a different parity from sum of A is removing the minimum odd number. These are such simple problems. These are such simple problems. Taking sum of a set and finding the minimum minimum odd number in that set. And then from here, everything is good. From only good things are good. These things are that simple, and these are good problems. If you solve this, you may get some high in the contest. Why the fuck? Use colors some map. See, why the fuck did you read editorial? You should have tried a bit harder. Who is Try? Is it Try Dangal? Not Dangal. I forgot his name. Uh, 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 I think it shows the full name. I have seen someone try Dalal or something. I forgot now. Mm, yeah. So this problem is a good problem, right? Lokesh, do you think it's a good problem because it doesn't involve big things? It doesn't involve topics. It involves logic. That if you want to get the maximum sum of different parity from the whole sum, you just have to remove the minimum odd number. So Lokesh, can you say if it's a good problem? Yeah, it's a bit good problem only, right? So if problems are good like this at this level, why do we not solve them? See, it's just 20 minutes and I have solved with some help from Lokesh. I could have solved it without his help too. I could have solved it in 5 minutes too because I am a bit pro. So now I'll code it. You guys can see how a pro codes now. So this is a very clear solution. I will find sum of A. I will find the maximum sum with other parity, and then I have layers. I'll just remove those things. Done. If you're lonely, come be lonely. Are you? Are you lonely? So you guys should not get scared about graph problems immediately after looking at them. I need views. I need viewers, guys. Like how can't you people just even stay for 22 minutes, 20 minutes? That's why I can see why you guys are not becoming grandmaster like me. Even I'm not. Just joking. See, I'll tell people why you guys don't solve difficult problems. Why you guys don't solve difficult problems is you fool yourself like, oh, I cannot solve them. They are too difficult. They involve great ideas. Because that sounds safer. That sounds that's more comforting to tell to oneself trying them or I can do them, but then I mean, I'm not able to say it properly, but that's comforting to hear that it's actually out of my thinking. That's why I'm not able to solve, as if you're not the one to blame. That's comforting. That's why you guys tell that to yourself. But then, if you keep comforting yourself like that, like with lies, you won't become grandmaster one day, like I would in the next contest. Mm, so see how a pro solves now again. Int n m. What is the other one? L. I have uneven nails. If you're lonely, come be lonely with me. It's not just even comfort. Yeah, you guys have to keep on trying all the time, like not be problems. See, guys, hear me. Hello. That's why I'm asking. Try. Can you once confirm that, like, if you can hear me? Confirm, no? Lokesh. Yeah, what I mean is like it's not even about trying so hard all the time. It's about being calm and open. Like why cannot I solve a much difficult problem? Like just try to think about it. Just try to slow it. Just try to slowly solve it. What rating is that problem? Lokesh, is it like 2000? Because I will try next 2000. If you guys have problems, line up like I need 22, 24, 23 such ratings, right? So we are about to solve 1100 problems. So let's see. First we have yeah. I won't even maintain yeah. I will just maintain sum of a and min ordinate. Okay. Uh this is fine. I guess I won't even maintain sum of it because it's not needed. If x is odd, then see, these are the only things we need, right? And then let's just store on, let's make a BFS tree now. So to make BFS tree, I can use Q or I can use layers, layer by layer. I can use any of those. I don't know what to use now. What should I use? Layers or Q? Layers or Q? I will go with layers because that's more intuitive or good. So we have n layers. Layer 0 will have, I should remove this thing. It's a bit 1. So now from this layer, because I don't want to add to the next layer, that's why there won't be anything to add to the next layer too, but or I'll just keep it like so. We are at the current layer. What we have to do is what we have to do is go to current layer. We're going over current layer and add anything that's adjacent and which hasn't come so far to the next layer. I, I won't explain this algorithm much because oh, I should take this input too. I have to clear these things too. Even in last contest, I spent some time without clearing things. Right. And now, if not used or added anything we want. If you haven't added them to the tree yet, add to the next layer. If you're lonely, come be lonely. That's it. So we made our BFS tree. Now, so every layer that is less than or equals to some a, and so max bad length, let's say max bad parity length equals to sum a minus min o. If min o is too big, okay, all of this will be negative because sum of a can at max be it won't be negative. So let me make it clear. But haha, this is fine. No, this is also not correct. It's fine. I'm using long, so I can use a bigger number. 1a15. I don't want to use that, but it's fine. Because 1a15 is big enough. This times this is 2 into 10 power 9, right? So 1a6 is big enough. But 2 into 10 power 9 is also fine. I can remove this thing. Because 2e9 plus 1 fits in integer. We have at max n minus 1 layers. If I reminder 2 equals to sum a reminder 2, which means it's a good one. I need not use string. I think using string is unnecessary because strings are complex things, right? Let's just use arrays. I'm scared about strings too. That's why let's just use arrays. Make things zero initially. See, my compiler somehow is not allowing me to do this thing. That's the only reason I'm trying to write them like this. Guys, we're solving a 1900 problem, so if I less than or equals to sum a, we can reach this thing. If I less than or equals to min max bad length, max bad parity length, we can reach this. So what we have to do for all the things in this layer, we should just set their answers to 1. Guys, it's working, right? Is it still lagging? Lokesh, is it still lagging? Check your internet connection, I guess. Internet connection. If you're right with me. Not that bad. Actually, BFS will look less simpler than this, but then logically this is simple rather than using a cube, right? BFS looks a bit simpler than this rather than having 3 loops. I wanted to use this thing though. So now we are outputting answer. All we used is loops, and you people are scared of loops. You can't even use loops and a little bit of logic. I don't get how or why you people are scared of graphs. Probably this is the reason, because you cannot get correct answers. What? Nothing matches properly. What did I do wrong? Let's take one example. Maybe everything is reachable one. Or let's just take this thing to check it quick. If you're lonely, come be lonely with me. Did anyone observe any wrong here? Like, did anyone observe mistake so far? Had lunch. See, listening this stream, seeing that these problems are solvable, will make you people be more positive in trying more difficult problems. This, other than, if you don't know, if you cannot see how you can solve difficult problems, what happens is you may delay progress a lot because you think, okay, I have to first do this less than or equals to 1900, this Bayaka sheet, and then only I can try the difficult problems. All that is bad for mine. So if you see these things, like see my streams, you can solve and improve much quicker. So these are the only 2 things that we are using, right? And what's the graph? 1 2 1 3 1 4 2 5. It just has, it's a tree with 3 layers, and the total sum is, so we have an odd number. Why the fuck did that happen when we have an odd number? Okay, all these are even. 300 is not odd, 200 is not odd. Don't clip this thing and then say we have a fake proclaimed grandmaster or fake international master who thinks 300 is an odd number. Don't do that. All of them are even, fine. So we can only reach 0, which is 1. We cannot reach 2 3 4. We can reach 5. So 1 and 5 should be the answer. But what happened? So I'll print the layers and check what happened. Okay. What the fuck? See, this is just this one mistake is fucking us up. Added. Still, it's wrong answer. So now we have one and this. How is this wrong now? Sum is even. So 1 5 should be getting that. This is a mistake. Fuck. Printing answer was the mistake. I won't make more mistakes like this. So I think this works. This is correct. So it's correct. A 1900 problem hasn't been solved. I can watch my streams again and again because I can see myself. Haha. If you're lonely, come be lonely. Are you lonely? Are you lonely? I'll be the only dream you seek. Okay, we made a mistake here. Because, did we? Because, fuck, we made a mistake here. If there's an edge, okay, we can reach all these things too. We can reach all these things too. One minute. So this is what is the maximum batch sum we can get, right? Fuck, I should not be here in our solution before going for implementation and doing all these things. Like we should be very careful. So that's a mistake. We can also reach sum of a minus 1 if there's a using even parity, if there's an edge that lets us change parity. What I mean with this is what I mean with this is we can using sum of a itself, using sum of a, we can reach more things. Fuck. See, uh, if it's a bipartite graph, like means there is no way that we can change our parity of layers, then see we can also reach some odd layers with the same parity itself. So now we have to think about them. Do you guys get what I mean? What I mean was we have two viewers now. Studio lights. I'm increasing my brightness. Oops. Fuck, I should be careful. So what I mean was these are layers, right? I can't spend this much time on a 1900 problem. So if there is an edge between these two, like this, then we have an odd cycle here. And when we have that odd cycle, even, odd, right? When we have that odd cycle, one, two, three, four. So we're able to reach odd ones using four steps. One, two, three. So we did something without changing parity. So we when we have that scope, come back. But now, how easy is to find such vertices which can be reached with sum of a by touching some odd cycle. So we want, it's like a bit complicated, right? It's like now we're trying to find the nearest odd cycle. So see, if you see BFS tree, edges will either be like this or like this. They won't be too far apart. That's why you cannot, this is the best path you can go, because at each moment you can only go one layer, because edges are, all the edges are like either adjacent or in the same things. So that's why it's like the minimum path. That's the reason. That's how the algorithm makes the other edges to be apart, because if they have been like this, we would have added this in this layer itself. We would not have added it here if there was an edge like that. So I'm explaining BFS tree too. So don't think that I'm taking so long for a, yeah. So don't think that I'm taking too long for a 1900 problem, because I'm explaining a bit of BFS tree too. So now this is the concern, right? This is the problem, that we can, even using even good parity, we can reach some layers that are not in that are in bad parity. Let's say this is the good parity, even is the good parity, some a comes here, but then we can also reach these things even if there is no odd number. We can come and then reach these things. So these things are the only complicated things, right? So let's try to see them. So if you see that any odd cycle, this is an odd cycle, because if you use an edge that lies in the same parity, that will be odd, because parity changed, parity didn't change, parity changed. So let's look at BFS tree once. How to use this thing? Ah, so we have BFS tree. So let's say this is the first odd layer we got. This is the first edge we got, because this is the edge that helps us change parity, because there can be edges from here to here because it's BFS tree. This is the first one, nearest one we got. The nearest one we got. Okay, which means we can use this thing to reach, and this is some a, right? This is some a. So we came here using BFS tree, and then we use this edge to change our parity. Now we can reach everything that comes under this thing. That's fine. Using, we can reach all the bad things that are under this thing. But what about other things? Is what we should think about. Is it that complicated now? Fuck, I'm not able to solve 1900 itself. So let me think for some time. We can reach all of these things, but what about something else that's here? This twice is bad. Anyway, if that is coming from top, we cannot reach it unless we come here and then come here and then go back and then come here. Sorry, we will go back like this. We'll go back like this and then here. We cannot reach it. So let's try to think about them logically. If you are reaching something else using even parity, but then you use odd number of these edges, which will let you not change your direction. Okay, let's look at that optimal path. How difficult that structure can be. Let's try to look at that. So you must reach this because you must use one of such edges because you will you must use one of such edges because you will, right? All odd summations. Now using all even summations, the man using same parity. But now such edge or few odd number of such edges, what all can we reach with length less than or equals to sum of a is what we need, right? So let's say this is one of the edge that we are using in a path that takes us here, total length being less than or equals to sum of a. So now we have this thing and we have these two, right? So the answer would be for this, we must come till here, right? This length. And then there is a minimum distance from here to here, I guess. Maybe it is like going above and then coming below. Maybe it is. But if you're using this edge, the best path is minimum distance from here to here or minimum distance from here to here plus this one. If we are must using this thing. But can we find minimum distance for all pairs? We cannot. So maybe there is a bit more logic that helps us solve this problem better. Okay, so let's try to see that. Let's try to see. But this definitely matters, right? Uh, because we can have a tree. We can have a tree where this is the only odd thing we have, and then we have other nodes. So this is the only odd positive here. And then what now it matters is how to go back matters. But how difficult is that to compute? Like, if we know, can we brute force all such edges? Can we brute force all such edges and then try to again find the shortest paths? If n is much smaller, yeah, we could do that. But let's try to again use a bit more logic. Maybe maybe something can help us here. Using sum a, what are all the vertices you can reach by touching one of these things, so that you will cover the opposite parity ones too. Damn, if 1900 takes this long, is anyone there? I can try to solve it. We can solve it because our stream is to show how we can solve difficult problems, right? So let's take this example itself. Maybe 1, 2, 3, 4, 4, 5, 3, 5. So that example is uh, 1, 2, 3, 4, 5, 4, 5, right? 1, 2, 3, 4, 5, 3, 5. Okay, that example is this. So we have an odd cycle here. So we can use our total sum, which is a lot, to come, and then reach everything using the odd cycle. So let's just think about that. This must be solved because the total sum itself can be, sum of a can be the only element in a, right? And still we should solve this problem. I mean, a having multiple elements cannot help us because we must solve this problem. Like, sum of a can be the only thing in there, in the set, and still we should be able to find what all can be reached using one of these things. Let's solve this somehow because we must solve that somehow. Mm. One thing is sure: if sum of a is like greater than or equals to 2n, everything can be reached, right? That's true. If sum of a is like very big, everything can be reached. But if sum of a is smaller, I will charge my laptop. Mm. So we have to, using odd number of these edges, what all can we reach is the only question we have now. Is the nearest one helps, smallest one helps, that helps in a way that we can use that, we can come back, and then we can reach everything. In that way it helps. So what is that? Let's say this is the smallest or nearest one we have from 1 to reach. This can help. If this length is L, maybe we can reach everything at a distance sum of a minus L1L, 2L plus 1. So this is one possibility, but it need not be this behind. It need not again go to 1. It can be L plus 1 and some behind and then come down, because that's why I'm telling shortest path from here to vertices, shortest path from here to vertices, right? Shortest path. Even all of them can be visited. Lonely, can be lonely. Are you lonely? Are you lonely? The only dream music. Doesn't seem that easy. Should I go to next problem? Should I try another 1900? Because problem is a lot. It may ruin stream if I take this long for one 1900 problem. This is everything less than or equals to this is also reachable, but this is not complete. We can have, as we can see here, we can come back till here itself and then we can come again down. But let's at least try to see if the shortest the first this is itself is the optimal. Maybe then we will try to find shortest paths from here and shortest path from here, brute force everything. Let's try to at least try to get the logic that, maybe try to get the logic that, damn, this is not that easy problem, that always using the smallest this thing is optimal. Let's try to at least use that logic. Okay, let's say, so now we have to compete between these two things, but that's also not true, I think, because you can use this and then you have to go back a lot and then come here, right? Rather than doing all this, you could have just came here and then use it this. You could have just came here and then used this and came here. So even this is not optimal to do the shortest paths. So guys, to not ruin the stream, I'll come back to 1900 again. Is that fine? Because I cannot get stuck in this problem now. That doesn't seem that simple to me. So to not ruin stream, what am I doing now is trying to solve some other 1900, because stream should be good, right? So I'll try to solve this quick and then I'll go to 2000. That will just take me like 10 minutes, I guess. You have seen editorial. I will not open your submission. Maybe I'm missing some small thing. I'll come back to this. Let me solve some other 1900 and then go to 2000 and then another go to another 2000 and so on. Okay. Mm, the beauty of an array B. If you haven't seen editorial, maybe I would have opened. But uh, see, what's the complexity of the problem? It's that's it. I mean, not that's it. It's we must do these things. We must use something, and then we need shortest paths. I just don't get. Maybe coming from behind, will that help? Can what are all the vertices that can be reached in some of? You can reach till here. what are all the things that you can reach is their ancestor. Like it's like there is a shortest path that just takes one thing and then again comes down. It's like that should be the possibility. The possibility should be there is a shortest path. So it's again coming like the shortest distance only, right? Like we are again trying to use the shortest distance things. So it is at least that complex. So I'll try to use solve some other 1900. I'll try to solve some other 1900 and then go to 2000 and then go to 2100 and then come back to this. That should be fine. It's 1 hour already. But 1900s are not are easy, but I don't know why I'm not able to solve this. So let's try the another problem. Lokesh, are you there, right? At least because uh, we must move forward somehow. The beauty of an array B of length M is defined as maximum of Bi XOR Bj among all possible pairs. So this is the beauty of an array B. I should have been careful in the beginning itself before going to implementation. That took a lot of time, right? This implementation. So I should have been careful here itself. While solving itself, I thought about that. Okay, bipartite graph or not matters, right? But let me come back later. I'll come back to that problem later, but it should not be very difficult. But it seems like we should do at least that much. Maybe, maybe for any vertex that has something odd in the same layer, all those things can be reached. But that's still shortest paths, right? We cannot brute force for all pairs. That many shortest paths we cannot brute force. So let's leave that. I'll try to solve this problem. It's fine, right? Who is the other viewer other than Lokesh? So let's try to solve this problem. Okay. An array B is called beautiful if f of b greater than or equals to k. So we have f of b, which is array B, f of b equals to max XOR among all pairs. So, and then array B is beautiful if f of b greater than or equals to k. See, not solving a problem is also learning. You guys should learn that. We are not here to get some highs of solving a problem, right? We are here to learn. So that's also fine. And I'm still trying to solve one more 1900 and then go to 2000. So it's fine. I can solve them quicker too, but I'm trying to go slow. Recently, Kotsia bought an array of length n from the store. He considers this array too long, so he plans to cut out some beautiful subarray from it. That is, he wants to choose L and R such that L to R is beautiful. The length of such a subarray will be the number. Yeah, that's known, right? The length of the subarray will be the number. Yeah, that's known, right? The entire array A is also considered a subarray. Okay. Okay, so this is very direct. Somehow it's very direct. We want length of shortest beautiful subarray in array A. So this is a bit direct. So this should be a doable problem for anyone because it's almost direct, right? Fuck, bro. So it's only you. Are you trying to support me by keeping that number high? Okay, one viewer is a lot to me, really, because if there is one viewer, I can interact, I can try to explain to them. Where is next to Durgesh? I think that guy should be jobless, right? Let me just see if he's there somewhere. Uh, 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 one minute. So, but this problem doesn't is also like this also doesn't seem to use any topics, right? This also doesn't seem to use any topics again. So also that's a good one. See, it's very direct here. The minimum length L segment L comma R such that f of a to L are greater than or equals to k. If nothing is there, we have to output -1. So we have to actually solve, and it's not even about the segment. It's about the pair. So this is the problem. They are telling subarray and shit, but the problem is we want to find the closest pair such that the XOR greater than or equals to k. So the problem is very clear, right? So 7 a.m. If there is a Dijkstra kind of algorithm that says minimum odd length to reach and minimum even length to reach, then we are done. But the simple logic that I'm trying to use is not helping. So because now you have told me, maybe we can try in that way. If you try in that way to reach So if you try to look at these two things, minimum even length distance and minimum odd length distance to reach some vertex v, then then it makes, if we can find these two things for all vertex also, then we can solve the problem. But then what I was trying for is to see a simple way, just using BFS tree, to use a simple way, because Lokesh has also seen solution. This seems to be like some Dijkstra, right? Simplest even length and simplest odd length, this seems to be like Dijkstra, but uh, minimum distance using even length and minimum distance using odd length, if you try to make these things, okay, let me try to add. So let's try to do this type of BFS. Is it a modified BFS? Have I never came across this thing? It's a little bit modified. So it's like Dijkstra only. BFS is Dijkstra only, right? So we are again trying to do Dijkstra. a dig that looks like a straw, thin dig, but maybe long at least. Then let's try to add. Let's try to keep two things. When added, let's try to keep its. We will keep that it is added, and we will also keep that. We'll also store the layer where it got added. Okay. If added, reminder 2. So now what we are trying to do is, when we are here, when we are here, we don't add this, right, to this thing because it's here. But then we're trying to add this to here, telling that this is the minimum odd length that's possible for it. Minimum odd length thing that's possible for it, type of thing. You guys get what I mean? So maybe that covers everything. So let's try to see that. I have never done this. Maybe I will analyze this algorithm a bit more. We need two things then: added even, added odd. Mm, So let's think about like this. This is our new BFS tree where we have for each vertex an added even thing, that it has been added to some even layer and it has been added to some odd layer. Okay. Using smallest paths. I've never done this, but let me try. I have to think properly before trying, but I don't know. I'm just trying. Added eve of 1 equals to 1. So this has been added to even length, right? This hasn't, one hasn't been yet added to some odd length. So now what we will do is, if I reminded 2. So currently wherever we are is at an odd length. So we are at an odd length. If added O, so we'll go to an even length of U. If this is not, then we will add that too. So every vertex can appear twice now. In our BFS tree, it can appear twice. I don't know why am I taking such risks in a stream to try something like this that I haven't tried any time so far. Add that again. We won't be adding vertices many number of times. We'll add them at max twice. Because once we are adding, we need this, and other time we are adding, we need that. Else, if not added. Oh. This is like a bit extra, but it makes a bit sense. It makes a bit sense. A bit sense. If it is correct, I will try to prove it. But then people will lose interest, so I may go to next problem too, if it is correct. So this doesn't need any change, right? Because now if it can be reached with even number of steps, it would have been added to that even layer. and then this will give us the answer. So we are just setting, so nothing else needs to change. So let's try to see if this will work. I tried so hard. What the fuck? I'm gone too far. How will this work though? So we have one, two, three, four, five, five, four. Let's also try to extend the layers to a much bigger one. Because now it can go so far and then it can come back, right? But still, but still, a simple path. Yeah, maybe it takes that much time sometimes. Is this right? I never use this with my huge amount of experience that I have of solving such difficult problems. Even trying 3500s. I never used this thing. But this seems a bit correct. But I have to prove it very clearly if it is correct. So now is there a way that finds minimum even path and minimum odd path for all the things? See, Lokesh, if you have already told that this is what I have done in solution, I haven't seen this part. This came originally with a little bit of help. I have seen his comment of saying something. Mhm. Let me submit this and just check it if it works. I mean, someone gave me agree because I have seen. I don't know if this is a technique that already exists, but if it's correct, it's a win. It's a win even by using 1 hour because I'm learning something new because that I haven't known. But it seems correct. It seems greedy. It seems a bit greedy. What's the minimum odd length path we can get? I don't know if it's greedy or not. If it's wrong, it's wrong. If it's right, it's right. I cannot act cool and then try to explain and then it shows me wrong answer. Why the fuck it is so slow? It's slower than me. Do you have viewers again? We have again viewers. Too many cases is complicated. Blue and black doesn't match, right? I know. Wrong answer on test two. Is telling that I'm showing my supremacy again. Uh, Now it's a bit difficult. Is 2n? Can it be more than 2n? From here to here, shortest path, and then from here to here, shortest path, and then from here to there, shortest path. Less than or equals to n, less than or equals to n, less than or equals to n. That cannot be. In the worst case, this may be, but let me be clear. These things can be reached. So, what all can be reached now? Let's try to make the solution very clear. We have Among all good parity, everything else has been reached. Guys, I should do something. Should I do G or should I do D? I mean, the other problem. We have viewers too. Wait, Lokesh, is it entirely different one or is it like a very close idea to this added E and added O? So this should not be the case now. One minute. Okay, this should not be the case. I need not match now. I don't get it now. What are we finding? Shortest odd length path and shortest even length path. So shortest even length path, if that even length path from top, shortest even length path is less than or equals to, and shortest odd length path, because this is the maximum odd length we can have, less than or equals to this. This seems okay. Should I try to store two L's? Is that how it works? Hmm. I mean, I'm adding them twice, right? What is the idea here? Shortest even length ones and shortest odd length ones. I'll just submit once again because I think 2n plus 1 may not be the issue, but can I go to this? I should not. That seems weird. I should not see those things, I know. Uh, but people will unsubscribe me if I do such things. I'll get some water. Uh, yeah, so this is also fine. This BFS greedy seems correct because now this is a bigger tree that has it's like this extra only. Just we're trying to we will have two instances of everything. One represents the minimum odd length it can achieve, the shortest odd length it can achieve, and shortest even length it can achieve. But then I have never used this idea so far. Damn, that's a bit learning for me, I guess. But so should I try? So see, guys, this problem is again a 1900, but then this just says that gets simplified to this. So if there is a path, so for every vertex I, maybe we will find from remaining if there exists something greater than or equals to k. This also will not be very difficult. It must be just some logic. So I will come back to this 1900 later because our stream says we have to solve 2001s, right? And we have a 2001 here by Lokesh. So now we are going to 2000. So, okay, this had something new, but Dijkstra or BFS type of Dijkstra, I cannot say like, okay, so I tried using more logic here, but then it's not even more logic, it's even more brute force again. Do you guys see this is a bit more brute force trying to find the minimum odd length and minimum even length in some other way. We know the minimum odd and minimum even can be achieved from the set A or sum of A comma sum of A minus minnow. That's one thing. And the other thing is just brute force trying to find a brute force solution for the minimum because as we have taught for logic there was no simple logic that we can try to do something like Dijkstra because we have only two states like minimum even length and minimum odd length. So this is like Dijkstra minimum even length and sorry this is like Dijkstra only like but layer by layer, right? And we have two things, so that's like a bit Dijkstra. So there's no light here. Yeah, so now I will try 2000 problem. So to comment overall, I have used more logic unnecessarily when such a simple thing will work. So it's like two things. One is minimum, maximum even sum you can get, maximum odd sum you can get from the multiset A. Maximum good parity is sum of A. Maximum odd parity is remove the minimum one. So that's one set. The other set is brute force. If you look at it overall from high level perspective on this problem, just the brute force and simplest one. So it's not a difficult problem. It should not be a difficult problem, even though it took this long. Let me go back to the other problem, 2000, like he told. Lokesh, can you confirm? I'm working at Apple as a software developer. But Lokesh, are you there? Yeah. So that has been solved by my team probably. I will see if I have solved the problem or not. So if you see these things, I have solved the problem. So as I have solved this problem already, I will not be explaining it here. It's me who solved the problem. Like we both gave that contest, and I have solved it here at 53 minutes. But I have also solved some problem. No, we didn't do good at all. We only did two problems. I have solved H. I have solved logically, but I was not able to code it. These were submissions made by him, my partner for that contest. J has been solved by me, and that's it. We didn't do anything good in that contest. Damn. So we can just at least see that this doesn't involve much complex things. It just uses some logic. But yeah, I can be solving it now because I solved it already. Sorry, Lokesh. I get it. Maybe I'll do it. See, as I remember the problem, it involves some logic that the smallest. Yeah, you can read my submission now. Try to read my submission. That will help you a bit, maybe. Because if you read my submission, I wrote some solutions there, right? I might have written good solutions. See, every wine changes its position. So white wine in the first 10 must pair up. Then S, else no. From the left, we have missed that. So we let's leave it. So these are the two conditions it becomes true that number of W's before R should be greater than or equals to number of W's after it before first R. So you have to think about this, I guess, because otherwise you probably cannot split them. Number of if there are lesser number of W's before the first R, all those W's go here, and then I don't even remember the problem, but all those W's go here and then R goes here, and then so in one way try to get the necessary conditions and then you can realize that they are sufficient, like always. Is that 2000 rated problem A in that contest? No, right? It's a much harder problem. It wasn't done by me in the contest. uh, uh, uh. Bro, give me one 2000 rated problem that I have not solved. So Lokesh, I'm not solving J because I have solved it already. Maybe I'll try that for 2300. Okay, maybe I'll try that for 2300. So for now I'll just choose some other 2000. So we are at 2000, guys, and I bet I won't take longer like I've done before, because the previous problem I was using something that I haven't used before it. We won't use that long for other problems. See, this is a 2000, and how quickly I might have solved it. Not too quickly. I did that in stream. I can solve quicker. So let's try to solve this one. I've tried this. Guys, I have tried this problem sometime and then I was not able to solve this, I guess. Small operations. This problem I have tried in a stream and then I was not able to solve that. So I won't try that again. Is that fine? Because I have tried that same problem uh, in this stream. So you guys can see that not solving problem one. So I have tried that problem here for so long, and then I was not able to solve it. So Let's not try that again. Okay, I won't try that again, so I'm leaving that. See, some problems we just can't solve sometimes, so we have to try another problem. I'll try to solve this problem as quickly as I can. Okay, that works, right? So guys, now we are at 2000, we are attempting a new problem. So try to think about this problem now. It's difficult because it's not so entertaining, right? Like CP problems are difficult, and then but then I want to prove a point that these are not, this doesn't use big things. So let's try to see what this may use. You're given two non-negative integers x and y. You can number of times choose a positive integer k and divide either x or y by 2 power k. Rounding down, so floor division, it's like moving them in bits. This cost of this operation is 2 power k. However, there is an additional constraint. You cannot select the same value of k more than once. Your task is to calculate the minimum possible cost in order to make x and y equal. So what does this mean? To make 0 and 1 equal, we divide by 2, right? So this seems a bit simple problem, right? In some way it's simple. At least you wouldn't need a topic to solve this. You all agree to that, right? You need logic. I think yeah. So as we have viewers, let's try to think about the problem. If anyone has any views, they can try to write their views here. I'll try to read them. See, nothing comes under any category. All of them uses logic. Even if it is a bit ad hoc, we have to see what logical points you can make. We can make some logical points, even if it's totally ad hoc. From the problem, thinking like, okay, if there is a simple solution, okay, I have to give problem link. So let's try to think about this problem and solve this problem. So it says we have x, we have y. Can use k and divide either of it by 2 power k. Can use same k more than once. So dividing by 2 power k is nothing but this thing, right? And this thing. And we need to make x equals to y after these things. So we have one k1, k2 up to so on, and then we have again some other k1, k2 up to so on. After all these things, we want them to be equal. Damn. So this seems very direct, right? So you're leaving, right, Lokesh? And you will come back later, probably. I hope. For the next problem, at least. Yeah, we can think of shifting bits to make equal. So this is very direct. So also this 2000 problem is not that difficult, right? It's not like unsolvable. It's not like you need some topics or you need some very great logic to even work on the problem. So I won't talk shit like I'm talking now, because then I was not able to keep up. I was not able to solve it. So if x equals to y, we have a leading bit. We have a leading digit on x and on y. What should we output finally? Minimum possible cost. We should output minimum possible cost. And the cost of that operation is 2 power k, which is fixed anyway. So to move k bits, we need 2 power k, right? To move k bits, we need 2 power k. So now to make x equals to y, look at x. It will have some 10111. Y will have some 101110. All we do is write shifts. So let's say their common prefix is this, and then it comes 0, and then it comes 1. So one of them is x and one of them is y. So let this length be L1. and let this length be L2. Okay, so we have K1 plus K2 up to so on equals to L1, and K3 plus K4 or something up to so on equals to L2. Or we can add few more things here, plus Z, plus Z, and we need minimum of 2 power K1 plus 2 power K2 up to so on. So this is the problem. So is it like after you fix, let's say you're fixing Z, Z is whatever you add from here to. So till here it's clear, right? We have some common prefix and then they differ because one is 0, one is 1, and then we have length of L1 and L2. What we must do is we must remove all of this, we must remove all of this, and then we can remove few more. So we must remove L1 plus Z and L2 plus Z, and we have constraints that uh, we cannot use some K multiple times. That's the constraint we have, right? Can you do my profile review? uh, uh, uh. Is that true that we have to find max common bits and then do the right shift? We don't know, but uh, this is max common shift. I'm adding jet, that's why, right? Maybe we have to add few more because it may not be optimal at all the time, right? Because we can take, see, it may not be optimal all the time somehow. So is taking them together the best thing we can do? So let's say K1 plus K2 is there. All these things will not, if we take them together, instead of K1 plus K2, the cost of this is 2 power K1 plus 2 power K2. But if I take 2 power K1 plus K2, that is definitely much bigger, right? So we have till here L1 plus Z. The question asked by Prism X is should we take Z equals to 0 for optimal? Let's not worry much about that because we can anyway brute force on Z. Maybe Z 0, Z 1, Z cannot be much higher, right? So we can anyway brute force that. So let's just think about this problem. We have two values, L1 and L2. Okay, let's say Z is included. Now let's think about this problem. What's the minimum cost we can get using distinct of these things that add up to L1 and add up to L2, and then we want minimum to so on, where some subset, where total sum of k's add up to L1 plus L2 and some subset adds up to L1. So this looks a bit complicated. Probably it's brute force, right? So these are the constraints we want at least. So taking 2 power K1 plus K2 together instead of doing 2 power K1 plus 2 power K2, this is always much bigger because this is 2 power K1 into 2 power K2. But then, so unless, yeah, this is always bigger unless K1 or K2 is 0, but then they are not 0. If they are 0, they are not of any use for us. So guys, if there are any new people, like the video because we have only 4 viewers still. I have to keep going, right? So if we can split something, splitting is the optimal thing to do, right? So having smaller things is always good. Having smaller things is always good. So what would be the optimal way? Maybe can we brute force for all lens, for all possible lens? Can we brute force? Can we brute force for all possible masks? That I am not sure. So it's like disjoint numbers, splitting this into disjoint numbers, 1 plus 2 plus 3 up to so on. Let's try to think of this problem now. Hi Hitachi, what are you telling? I'm not able to know. X and Y are this big, and we can answer it very quickly because 10 power 5 test cases. We can answer it in log n. So what is the optimal way to split? What's the optimal way to split? So because these are two powers, okay, first minimizing the maximum's value is optimal, right? Minimizing the maximum value is optimal. Why? Because it's sum of distinct two powers, and for two powers we have 2 power k greater than 2 power everything below, 1 plus 2 plus up to so on k minus 1. Because of this, because of these two power things, we can say about the cost rather than trying randomly if taking 1 taking 2 is optimal, or taking 1 2 3 is optimal. Rather than thinking of such useless things, we try to use logic. Then we can say this thing. We can say that if you have if you have the maximum k that you have used, if you can make it smaller, that's definitely optimal than k being this. So now the question comes, what's the maximum k with which it's possible? See how the problem has been solved. Do you guys get how the problem has been solved? Where are you people? Hello. Bro, I'm explaining a problem of 2000 rating, and I'm explaining it well. And then you are talking about some lead code problem. See, I got it. I will try to explain it later. But now the stream is 19, 2000, 21, 22 up to so on. So I cannot explain it right now. Yep. Uh, so Prism X. I hope you followed this 2000 a problem, right? Yeah. So do you see again how we're using golden rules here? Some solutions came to my mind. Taking 1, taking 2, taking 3, taking 4. Maybe is that the optimal? That came to my mind. But then we cannot prove that solution easily, right? That it's true. So we should not be thinking in that way. We should not be going in that direction because we cannot prove it simply. But if you see this solution, that this is a good very logical one. So when we try to think, we have to have our golden rules in mind, and we have to have the problem statement in mind. Problem statement says case or distinct and the cost is 2 power k. What does that scream? That screams minimizing. The highest k is the optimal thing you can do. Do you get that? I got that right. So now so now we can have a dp now. So we have L1, L2, and then dp of L1 and L2 will give us, if L1, see, dp is brute force. Dp is like brute force always. No, I got you. I got what you mean. So now what we want is, we want the maximum k for which there is a way to use that k in some of these two, and again split everything in a disjoint way using less than or equals to k things. Right. So maybe I can have this thing. dp of L1 and L2 says, if L1 and L2 are the lengths needed, it gives us max k that can be used here. If it's impossible, it gives us 0, let's say. So let's say this is the dp. So why am I telling is, sometimes it may be impossible, right? Let's say it is 1 and 1, 1 comma 1. 1 comma 1 is impossible, right? You have to use 1 at both places. So that's why it becomes we can do brute force now. We can do brute force over all pairs, because L1 and L2 are just two small numbers, right? So if you have this such a thing like this dp, maybe you can even have dp of L1 and L2 and k, if it is possible, by using k in one of those things. But let's try to have this. So L1 and L2, this will give us maximum k that can be used either in L1 or L2, and we can proceed further. If it's impossible, if it is 0, if you have such a dp, we are done. See, dp is nothing but brute force, right, in what we want. Thanks Prismax following up. But do you guys do you see how I solved this 2000 problem much easier than the previous 1900 problem? So we cannot, because I used something new in there. I never used something like this so far. This thing I never used again so far. uh, that's why I took more time, but this is getting solved very simply. And if you think about it, the problem itself gives the solution. Why is it 2 power k and disjoint? Those two itself scream that minimum k is important. And now if you have this thing like pre-computation, if you have this dp pre-computed, we can solve it instantly for everything. If you have this value, then what will we do? We can find answer easily. How can we find answer? dp of L1 comma L2, we know k is the maximum thing we can have. So let's try to see how to find dp. So we have L1, L2. So this dp will just say, or we can actually have the dp for the final answer itself, right? Why even complicate things? We can have dp for the final answer itself. Using dp to find this is also good. This is also enough. But let's try to find the final answer itself using dp. Okay, we have L1, L2 using mini is equals to minimum cost to construct L1 comma L2 in desired way. If impossible, it's infinite. So also this is fine. Also this is fine or this is fine, but this is directly gives us the solution, right? So let's try to just use this thing. Is that fine? Prism X. When it's impossible, 1 comma 1, 1 comma 1 is impossible to make, right? One comma one is impossible, but uh, what is always possible is you can always take 64, 65. This is always possible, right? You do one thing by 60 and then you do other thing by 61. They will be equal. That's always possible. So making both of them zeros is always possible. So we have uh, L1 plus G, L2 plus G, and in worst case, maybe maybe we can have making everything as zero. In the worst case, we can have everything making everything as zero. Making everything as zero. Is that keeping a one always good? Is one thing we can think of. Because if you are keeping a one, see, removing everything is also fine. Removing everything would also be fine, but still, I'm thinking about overflow cases. So let's try to limit the maximum value also. In worst case, let's think about the worst case. So in the worst case, it will be definitely less than or equals to 2 power L1 times 2 power L2, right? To remove both L1 and L2. Not answer, not the DP answer. If L1 equals to L2, then right. So this is like 3 times 2 power L1, and we have 2 power L1. Maximum number of length of bits we can have is 2 power 15 itself is much bigger than that. 2 power 58 itself is greater than 1 is 17, and we have here 1 is 17. So define n 58. So at max we'll have 58 bits, not even 58. 57 bits we'll have at max, because 1 is 7 is less than or equals to less than this thing, right? Not even 57, it's even lesser, but still it's fine. See, I'm just thinking about the cases where all these things can be brute force. Jet can be brute force, but then we have some other case where one of them is fully covered. When one of them is fully covered, when one of them is fully covered, how far can we go? L1 is fully covered. Is making L plus 1 better? L1 plus 1. Like L1 is fully covered, let's say. So the other thing, should it be L2 or L1 plus 1 and L2? We don't know, right? Like taking more is also may help in some cases, because this is brute force, greedy, weird ones, right? It's brute force, right? So we don't know. So I'm thinking about this. How far should we be going on this side? That seems a bit complicated, no? Like how far should we be going on this side? Maybe we have to apply some logic there. Should we do it right now? Do you get what I mean, Prism? Why am I trying to be careful? Hello, do you get why am I trying to be careful? I saw 14 likes and then it became 15. You're there, right? At least. Yeah. So, do you get what? Why am I trying to be careful here? Because mm, all these things are fine. I'm just trying to see the extreme cases where we have to remove everything. If you can prove removing everything is bad and then just removing these two is good, even then we are done. So let's try to see this thing. Instead of this, let's say we have L1 and L2. Okay, we remove L1 minus 1 and L2 minus 1. But the thing is, removing everything in L1 may have a better answer, because somehow the bricks got matched perfectly. That's why it may have a better answer still. You got what I mean now? But then using using 2 power L1 or 2 power L2 is bad. That's never needed. This is true. So there can be some extreme cases, right, where everything gets perfectly fitted, and then removing L1 plus 1 and L2 plus 1 is optimal than removing L1 or L2. There can be such things, right? So I'm thinking maybe we should consider them or not. So that's the only reason it's a bit difficult. So let's try to first make our DP, okay? Otherwise, infinite. What did you say about infinite before? You told something about infinite, right? Uh, 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 uh. So let's try to first handle these things. If it doesn't pass, maybe like then we can try to think about this thing, because thinking now unnecessarily seems unnecessary, right? So let's just think about this, because if it has involved this, it will be a much difficult problem because people cannot solve. But it must involve this too. I'm not very sure. So let's, if you see the DP, because I think even this is not enough, because I have to apply that this is the maximum k, right? I cannot remove one here and then try to remove bigger thing from here. I cannot repeat things. So this must be there. So this also must be there. Okay. So we should solve this problem now. We must use k because we cannot repeat things, right? And we have to also force like this is the maximum. So we must use k. So how should we make our DP structure now? L1, L2, K. Is this fine? So maximum cost with maximum ki less than or equals to k. Why are these problems this difficult? I don't think 2000 things should be this difficult. But maybe this is not difficult. I am not getting. Should we brute force, or else is there a simpler solution? There cannot be a simpler solution, right? Let's think about it. Should we brute force, or is there a simple solution? L1, L2, right? We must brute force. We don't know the smallest k that perfectly matches everything. So it's not that simple. So this is our new DP. So what we do is from k minus 1 up to so on, we find, let's say our initial DP is pos infinite. We make possible answer as minimum of pos comma. We use k of I, right? So what do we do? That will cost us 2 power k of I plus dp of L1 L2 minus k of I plus dp of, sorry, we need now this thing. The next thing should be less than ki. That's why I'm using ki minus 1. So less than or equals to ki minus 1 should be the next thing. So this will be the answer, just dp. Comma, we can also have 2 power L1 minus ki L2. So this is just that simple dp. So we can see that k is reducing. We can see that k is reducing. So we are going to smaller cases. That is there. We can also see L1 is reducing, L2 is reducing, either of them is reducing. So it's always becoming smaller. So if you have one base case, if you have base cases, I think we can proceed and then we can find dp for all the things. But what do you think? Should I try to worry about everything is being covered, or should I first try to code and then try to see for these things what's the best answer? See, even this problem is not like out of anyone's league, right? This is trying to do some simple brute force. To brute force, to force that k should be distinct, I'm involving three things now: L1, L2, and k. And finding common prefix, that should be simple. And writing this dp should be simple. So, see, there are no topics for grandmasters itself, bro. What topics can I teach for newbies and gray and green and cyan? The problems would be even much simpler, I think, at that level. So this itself is not a topic, right? This is a DP problem. I think rather than this, just the previous one helps more, I think, right? Is it this thing seems a bit more reasonable? Can is there something existing with this max k? This seems better than this thing because, but then here again we cannot force them to be disjoint, right? Because everything else must use So for this, the answer would be, damn, I'm being tired. Bro, problems cannot be this difficult. I don't know why this is a 2001. This seems a bit difficult to me. Should I do this or should I do this? All of them seems difficult. Wait, is there something that makes it very simple? There is no, we have to do this. Even this doesn't help because once we do k, we have to force the remaining things to be less than k, right? Maybe this will help. With using 2 power k, uh, does there exist a splittage? Does there exist a splittage? This is good, I think. Can you split them using 2 power k? Because now after you use k, you will remove, you will check for less than or equals to k. Really? But then I'm skipping every problem then. I think it's becoming bad. See, there are not much techniques, bro. It's like if we try to solve this problem, we may learn something now. If we try to solve this problem, we can learn something. But then I don't want to get stuck at 2000 problems, bro. This is too much. So we have solved this problem. Let me try some other 2000 then. I'm not able to proceed because this doesn't look that good to do. What maintaining three DPs, three things, three shit, but nothing else we can do here except this. I want to solve nicer problems, bro. See, I will tell you one thing. Are you there, Prism X? See, there will be more nicer problems as we go to higher ratings. This 2000 rating is shit rating. That's why it has such a shitty problem. Because isn't this shit? I'm not able to solve. That's why I call it shit. Just the fact that you have to use minimum k is the best thing, and then you have to brute force this shit. Does this involve any good things? Do you see that? So that's the level of logic needed to solve this level of problem. It doesn't demand logic. It just demands this. All you have to find is that, yeah, min k is the best thing, and then you have to be able to brute force from here. So if you go higher, there will be good rating problems. So let me choose some other 2000. Okay, I'm doing this multiple times, but I will choose some other 2000 and then I will go to 21, 22, and so on, because solving this now doesn't give us any teaching. Instead, trying to do another 2000 only is good for us. So let me try to solve this. Div 3 problems are okay. This is division 2, educational too, but yeah, maybe this can be a good one, but it doesn't look good. So let me choose some problem. Yeah, this seems nice. This wouldn't be that nice because it's this thing. It may be more implementation too. Expected power. This will surely be easy for me. So let me try to solve this problem. Okay, you guys can learn expectation. You guys can learn probabilities and shit. How I would solve such things, right? So let me try to solve that 2001. No, I will just choose random ones. I won't solve by. I should not go for easiest 2000, bro. I should just solve some random 2000. Otherwise, the point is lost, right? You got me now. So I will try to solve this one. So any I may teach any expectation related things too, if possible here, because let's try to see how to solve this problem. Just that's it. I have not solved it probably. So we are still at 2000, but I hope at least we cover some 2400. At least we should go till there. You're given an array n of integers. See, we have solved this one. That's shit. I don't want to try more in that. That's why I'm stopping it. It's not that I cannot solve it. You're given an integers. You're also given an array p1, p2, so on pn. Let us denote the random multiset constructed as follows. Can you hear me properly, Prismax? Can you hear me properly? Hello. Why aren't you one it? Lokesh is one. You have to beat him. Just spam W. You will beat him. So let's try to think about this problem. Okay. Let's try to solve this problem well. The previous problem is shit. You have understood it well, right? Yeah. So now let's understand this problem. You're given an array, and you have some probabilities. Or I guess initially S is empty. For each I, people are shouting outside. Wait, why is your XP not increasing? It should have increased by now. Okay, let's try to listen this problem. Try to listen this problem well. Okay, let's try to solve this problem. So initially S is empty. And then for each I from 1 to n, insert AI into S with probability Pi. Note that each element is inserted independently. So yeah, this makes sense. We have a multiset formed randomly. So see, Prism X, can you focus on stream 2 now? Bro, you are number one. Somehow it's scamming. Somehow it's scamming. Maybe if I reload, it will increase. I don't know. It's somehow scamming. Yeah. So whenever there are expectation or these problems, if it is like combinatorics, there will be much easier problems because you already know you can try to solve them. They're not like totally weird ones, right? So we have to have such confidence. I have such confidence. So even if you see in this contest, because I had that confidence in this contest, where I got minus 101, because I had that confidence, I went for C, and then I have solved C. I have solved C at 1 hour 30 minutes itself. At 1 hour 30 minutes, even though it's 2700, I solved C at 1 hour 30 minutes itself. But then I was making one small stupid mistake because of which I was not able to accept it, and then I have changed it and then it got accepted. That was so sad, getting minus 100. Even though I have solved 2700 in the contest itself. I solved A, I left B, I went for C. I left B and I solved C by 1 hour 30 minutes. There is still 30 minutes, but I was not able to debug. And then I got minus 100. Uh, but I know that I can solve that problem surely. Is it fine now? I hope it's fine now. Yeah. So let's try to think of this problem. Let f of s as the bitwise XOR of all elements of s. So f of s is bitwise XOR. Please, they're asking us, they're begging us, and still we are skipping problems. Please calculate the expected value of f of s whole square. Output the modulo 10 power 9. So this seems very direct to me, though. So we have problem statement. We have s. We have array A, P, and then we form S randomly, and f of x is XOR of S. We need E of f of s whole square. So this is what they are asking, right? Bitwise XOR makes it simpler because now each bit is a bit independent, right? F of S. Bitwise XOR makes each bit is independent. If it was addition, these bits will get added and then they disrupt or they spoil the other bits, right? But bitwise XOR seems a bit independent. So let's try to write like that. F of S equals to summation of 2 power I times XOR of Si. So if you only look at this bit, only consider ith bit. So this would be that. This is f of s, right? F of s is 2 power I times, if you're looking at that bit, XOR of that bit in that set S. This is correct. So far we haven't used any math. We just represented some simple way that bitwise XOR into individual bits. What is f of s whole square? F of s whole square is this sum whole square. So let me call this, so this sum of, let this be like fi for now, for notation purposes. So sum of fi whole square would be sum fi whole square. Let's try to expand this to, it is sum of fi square plus 2 times sum of fi fj, right? So far it's clear, we haven't used much of expectation things to it. Now let's, if you try to apply f of, I'm solving in problem statement. I think I should not do this. Let me keep it here. Solution. Equals to. Also, this needs work. There is no great idea or logic here, right? You agree that now? Fj is, a plus b plus c up to so on whole square. We can write it like a plus b plus c and a plus b plus c. Now we have to a plus b plus c up to so on, a plus b plus c up to so on. We should just multiply those two. It's like taking pairs. How many pairs we can take? AI, AJ, or AJ, AI, AI, AJ, or AJ, AI. So that's why we are writing it as 2 times AI, AJ, Fi, Fj. It's like over all pairs. I meant like I not equals to j. So it's like over all pairs, kind of. Bad notation, I got it. But yeah, so now it is expectation of, see, expectation of summations can be split among expectation of individual things, that we know. So it is like sum of expectation of fi square plus 2 times sum of expectation of fi fj. Okay, so till here it's fine. So now it's all simplified, right? So sum of fi square, what is fi? We just have to look at that bit. So what does sum of fi square means? Fi is either 0 or 1, right? If we keep 2 power I aside, it's either 0 or 1. So we can even, if we can get the 2 power I out, and then it's either 0 or 1. So what all we want is expected value of bit I being 1. So if you see bit I in the set S, so Fi equals to 2 power I bi, let's say. So if we have this expectation of this bit, Fi square is Fi only. If you keep this 2 power I outside, Fi square is bi. 0 square or 1 square, it's the same value. So we just have to keep this outside. So you see, even Fi square is not being that difficult for us. Yeah. And then this seems a bit tricky for us, right? This be probability of this being odd and this being even. but still it's just two pairs. It's just two pairs. We can find it some way. We can brute force, or we can do something and then we can find it some way. Right, because we can do it. There won't be, if we see those two things, there are n different things, but number of distinct states we can have is probability of them being 0 0, probability of them being 0 1, probability of them being 1 0, probability of them being 1 1. Those are all the states we have. We don't have too many different weird states here, right? And we can have these four states, and then we can we can repeat our process, adding this with this much probability or not adding that. Will how that will change our probability distributions of these things. We can have it for the whole array. So even this can be solved for all pairs simply. So we have this. So we remove this 2 power I 2 power j outside, and then it's just bi bj. And then when we are multiplying bi bj, we finally want probability of 1 comma 1. Even though that's, but we have to maintain everything. Otherwise 1 comma 1 can come from 0 comma 0 to 1 comma 1, or 1 comma 0 to if ai is having 0 and 1, ai is having 0 and aj is having 1. So we will maintain everything, but then finally we only want that. So it's simple, right? Four cases. So what we have to do is, for one individual thing, we should be able to find what's the expected value. This we want, and then we want this. Sorry, this is a bad notation. So we want for each bit vi. For each bit I, we want expectation value of that bit. We want this thing, and for each pairs of bits, I comma j. I hope I am not overkilling this. We will find probability of, what we want is expectation of b I times bj. I know that this is what we want because other things are 0, but we can just have the we can just have it like as probability of 1 comma 1, both of them being 1. Probability of both of them being 1. Yeah, that's it. We can just have it like this. To find this, we are maintaining four things. Up to so on. To find this probability of that bit being 1, we can maintain prob of 0 and prob of 1. Right. So how do we solve this now? Simply. How can we simply solve? Maybe we can just write loops. We can just write loops, brute force, total brute force, and total loops. So let's make this thing a bit simpler so that we can have our final formula. So let's find, yeah, we have everything. We have our formula, we have everything. We have fi, we have vi, everything. So I will try to code this. But it's a constant, right? Prismax, it's a constant, right? If you see all the values, 2 power I will stay same. It will get multiplied with 0. Yeah, 2 power I plus 2 power I plus 2 power I, right? If it is 0, it's still in the summation. 2 power I can be taken common. Oh, wait a minute. What the fuck? Just joking. I just meant like to take it as summation outside. So this is what we have, and if you think about that, this is a very standard problem. Trying to find the probability of a set being 1 or not. It's standard or not, it's simple. So let's just try to solve these things. in a nicer way. Let's try to solve them in a nicer way. Okay. So let's have this one. Sorry, integers right here. Where is modulo? Yeah. So see how I code too, because how I code is also important, right? We are trying to learn everything here. Uh, I can write them directly in loops, but then I'm trying to write them as functions. That takes an array of bits, an array of probabilities. Okay, should I just keep them as arrays? Because vector is scary, right? Array of bits two works. And returns what we want, prob of 1. So let's try to keep them simple. Okay, so we have two variables here, in p0 p1. So initially uh, it's 0, right? Nothing is there. Let's say the max value, the that bit XOR will be 0, right, when nothing is there. So now we are trying to use dp here. Dp type, like if we know probability of set without an, we can find a probability of set with an, the XOR of everything with an, because an can either be this or that. Based on that, it will change the distributions, right? With this probability, if it becomes this, it changes the distributions, right? So we're trying to do it dp. So when we don't use anything, these are the probabilities. So when we try to use something, so we, this is the bit, right? Now that is the bit. So if the bit is 0, either you add it or you don't add it, it doesn't change the previous probabilities, right? I can keep them as p of 2 2. uh, and now if you're adding it, so let's say these are our new probabilities. If you're adding it, so we are splitting into cases. This thing getting added with probability pi, or this thing not getting added into probability pi. That means in that case, that will try to change things little bit. So what I mean is, if this thing is getting added with probability pi, so we are trying to write that as that will be this will add, this will change the states into, what this will add is, this will change the states into, with pi probability we have this thing, or we can just have expected value instead of the probability. Having one is enough. Probability of becoming one is enough. So let's just have p. We need not even make it complicated, because let's just have probability of that becoming 1. The other thing is anyway 1 minus p, right? It's either 1 or 0. So just have 1 here. I wanted to keep it in arrays so that when we do two things, it will be more easy, but this is fine. So having two things is also fine. That will show how we will do the next one easier. Do we have viewers? Is Prismax is there? Yeah, so let's stop it at least here, maybe like at least 2000. If we solve, maybe I can stop then after 2000, right? I want to go to even further, but there is a contest at night. I was not able to achieve my objectives for this, but okay, if I solve this and if I solve 121, I will solve this and 121 and then I'll stop. Let's hope this will be correct at least. Should we have all? Let's have all. Like it can be that complicated, right? Let's have all. Okay. I instead of explaining, I'll just go and write the solution. So how does, so one case, so we have zero everything with pi probability, it will be b of I, right? With pi probability it is b of I. So what should I add is np of b of I times, so with p of I probability it is that plus equals to, so here use previous 0, p of 0, and p of times p of I. I think I should make it look simple, but I'm not able to do that. So we are trying to multiply p of I because that's the probability now we are trying to see. Plus, I'm complicating things because this is systematic, but I don't know if I'm doing it right or not. So if the previous thing is 1, it will look like this, right? Or I could have used a loop too. And now we have to add the other cases. Or instead of doing all this, if b of I is 0, we are anyway continuing it, right? So I can just do this too. So this has been done. So if the previous thing is, if you're not adding this, if you're not adding this, they won't change. NP of 1 will be same previous probability of 1, same previous probability of 2. This is fine, right? I'm not practicing now, bro. I'm not practicing. See, I'm just giving contests recently. If you see my previous year, not practicing. If you see my 2025, I'm not practicing much. If you see my 2023, I used to practice, I guess. If you see before that too, I'm practicing. If you see before that too, I'm practicing. So I'm not even practicing this just that much. I used to solve. See, I will tell how I practiced. Okay, I used to think 2200s are scary because I saw people using segmentaries or weird things. But then when I tried 2200s, they were not scary at all. I'll show how I practiced. This is not there now. See, I solved many 2200s at one point, and then I tried 2425. Then I am not liking these problems at all. I like these problems, so they are being nicer. So I tried many of them, and then I was liking 24, 6, and 27. So then I was just trying these problems, and then I tried these things. Now I like all of these. I guess I don't try only these things now. That's how it went, but I think I should do these things faster to increase my rating. So that's how I have practiced. After solving these a lot, I like these things better. You get it now? All of them are nice problems, bro, really. That's why I'm trying to do this stream to show that 24, 25 are nicer problems. But then People are getting tired. I should be getting tired, right? I'm talking, I'm trying to solve. Okay, this is fine, right? So, and then I'll uh, p comma np. I hope this works because now p comma np's have been swapped. Now that they have been swapped, the arrays np will be destroyed, but p will be stored. Addresses have been swapped, I think. So this is the prob one. This has been done. Seems okay, right? Seems fine, right? So now let's try to go and see this thing. We also have a bit here, and then again we have b1, b2, two bits here. Should I just treat those two bits as one bigger thing? So, bro, what I will have is instead of this bit, I will just have the two-bit number. B of I will be either 00 or 01 or 10 or 11. This also seems fine, right? Because I'm doing XOR, so I'll just keep it as one thing instead of complicating things. Okay, you got what I mean, no? Initially, it's 00. So P of 0 is 1. P of 1, P of 2, P of 3 or 0. So now instead of using these things, we use them in that way, like I have done before. I don't even care to continue now. I'll just do. I'll just do this. After having everything zero, there are two cases now. And one case is we are doing with pi probability, we are trying to add this, and with pj probability. Okay, there are four cases now, right? There are four cases now. With pi probability, we try to add that. With pj probability, we try to add that. Should I write a loop? Or should I write them as four cases? Hello. See, even this problem is a bit more shitty. It doesn't have any much logic, but it's having implementation. Little bit of implementations are simple if you make them simpler. How should I handle that? This is there, this is not there, this is there, this is not there. Four things are possible, right? Wait, there are two cases only, right? Wait a minute. There are two cases only, right? Why did I again get confused? I thought two bits, this bit can be that, that bit can be that. Now, there are two cases. Pi choosing this, not choosing this. There are just two cases. For int x equals to 0, x less than 4, x plus plus. Let's say you're choosing this, okay? You're choosing this. That will add np of x of b of y because you're choosing that. How much probability? P of I times P of x probability. So this is nothing but previous thing being x, we are choosing it. So that's why this is coming into picture because we are choosing it. And we are not choosing it. If you're not choosing it, np of x plus equals to 1 minus p of I times p of x. Let me have this as PA, probability of choosing A, or PC, probability of choosing. Then this will be PC. Wherever there is I, it will be PC. And this will be PC. PC. This will be PC and this will be PC. So done. This came simpler because I've used loop. Swap of what all we want is this product becoming one. Probability of one is what we want, right? So just let's just return that. Probability of one is P of 3. Is this fine? I used to use long back, but now it's gone. It's not working now. I mean, there are four cases. I thought there is like PI and PJ. Oh, okay. Then I'll try to use it on Brave. I have to shift then. When I have to use that, and when I was solving much difficult problems, I used to check like, okay, this many 2800s solved this week, this many 3000s have been solved this week. I used to check like that when I was solving. Now I'm not solving. Okay, now this someone had some other that shows our rating graph, what rated problems we have solved. Now it's not there. So, bro, you're following, right? I'm not working in any firm, bro. I'm working in a normal company, Apple. I'm working in Apple HDE. Not working in any head trading firm. So let's try to code this then quickly. So now coding should be easy, right? First, try to just find summation of fi squares. Okay. See, I will just write these things also very quickly. Int. I have template, but I'm just showing like how it doesn't matter. So let's handle fi square. 10, 10 bits. We have our answer, and then it's just expectation of fi square. What is fi? What does fi square will give us? Fi square will give us. Let me keep it as a constant term. Okay. So this was the constant term here, which is 2 power I square, and then we just multiply this with our probability of 1. So to maintain the probability of 1, let's have our array b of n. Okay, we fill this b of n. B of j equals to a of I and this thing greater than 0, let's say. That's fine, right? And then we had answer plus equals to C times fun1 of B P C N. So that's it. Codes are simple always. See, this is simple, this is simple, this is also not that difficult. So that's FI, right? It's like 2 power I into 2 power j into BIBJ, and then we just want the probability of BIBJ being there finally. I'll also multiply C with 2. Are you there, Prismax? Thanks for being there throughout. Thinking how we are you just this good and your J ranks are mind blowing. Like they are speak now for your logic stuff and all. Hmm. Uh. Okay. Whatever you're saying is, I think I just kept trying. I think on code forces a bit. I like solving. I guess that's the only reason a bit. But what I'm trying to help you people is like I'm trying to show that difficult problems are not difficult, and what you need is improving your problem solving skills and not some topic or like that. It's like fun trying to think, trying to make logical statements. It's fear that makes us not solve anything. So that's what I was just trying to say. My JE rank is luck in the sense I did too bad in paper 1 and I did too good in paper 2, because paper 2 was difficult, I did too good. If that was easy, I would have fucked up. If paper 1, I don't know, it was a bit random too. I think he's trolling me now. Try. So uh, yeah, so we have C. Now what all we have to do is, see, what I'm trying to say is it's not because I'm something, that's why I had everything. Not everything, I don't have everything. My job is also not too great, right? So what I mean is uh, it's just that if we try solving, we can solve. That's it. Because my code forces rating is not much, right? I should have been GM or something after solving these many harder problems. 91 2400 solved everything without even seeing editorial, and then 74 and still not being GM. That's the worst part, right? Like, so my rating is bad. I fuck up many things. I have so many flaws. What I'm trying to say is, it is not something great. It's like you just have to improve your problem solving skills by trying. So now we have to make our BJ again, B again. So let's try to make our B again. How do we make it? Same way. We have two things though now. We have 2 bits, and so this is 1 bit, right? Right. So that bit we multiply with 2, and then we have another bit now. I'll use K here. So what I'm trying to say you Prismax is you have to keep trying much harder problems too, because how is this that difficult? No, right? And when you try harder problems, you will improve your implementation skills to a lot more than otherwise. So what I'm trying to say is, don't slow your progress in mind, at least, because in practice it's difficult. Because even though you know you can solve much harder problems, you cannot uh, solve them in the next contest itself, but at least you will know that I can solve those problems. Somehow I have to increase my speed, be careful in contest, and then make them. But if you're like, I can't solve difficult problems, 2000 rating is out of my league, 21 is out of my league, I cannot try them at all, I cannot touch them at all, first I will do this 1200 now, and then maybe next year I'll try 1300. If you're like that, you're slowing your process, is what is my way of, or what is what my point that I want to show to people, that we can solve them. See, the implementation doesn't look that complicated, even though it's shitty problem. We have nice problems as we go above. So this is fine. I'm multiplying this with 2, multiplying this with 1, so we have 0, 0, 0, 1, everything that we have, that we need. And now we are literally XORing here. And now we have B, P, N again. I hope it will be right. If it's not right, I'll correct few things and then it will become right. So this is just my second problem in this contest, in this stream. That's so sad. Even though I tried 4 problems, one didn't come. See how simple this looks though. It is not looking too complicated, right? And then we are done with the answer. See, you guys cannot get such content everywhere, right? Someone trying to solve much difficult problems and then showing them to you people so easily. So everything's being wrong here. Bro, you told that before too, that you blame God forces for wrong answers. Bro, you got to be trolling me. Try. Uh, it feels like you're trolling me, but I hope you aren't. Even if you are, it's fine. I think. It's funny at least. So we can debug. We need not get scared again. It's simple. Let's try to see the most obvious case. XOR of that. What is this question even? So we have this probability 1, 1, 1. So it should be 1. So what here? This should never happen. 1 minute. This is not there. There is only one bit. All of them are zeros. All BIs are zeros. Most of the BIs are zeros because there is only one bit. All of these values doesn't contribute to BJ at all. So let's output answer here too. Or this works too. So here itself it's 3. So that should not be happening too, right? So C is 1. Because for other things we don't have it's nice that still people are there, and it's very nice that Prism X is there somehow. So we have to see. C is 1. How can fun of 5 become 3? Probability of 1 that being that much cannot become that much, right? We have PC of I, PC of I, previous thing being 0, and then we are making it like that. If B of I equals to 0, we are not changing anything, we're just continuing. Otherwise, 1 gets 1 because this is not being used at all, and then that gets 1. P of 1. So let me output this too. What this value should be? This should be 1. This should be, I don't know. See, in this case, there is only 1, right? So we had all the bits as 0. Only this has 0, comma 1. Then why the fuck did this become 3? This answer become 3. It cannot, right? Where is that answer? Most of them are zeros. We written P of 1. P of 1 is only 1 once. And if it's only 1 once, how can answer be 3 here? Is C wrong? One day, maybe someday, in a bad orchestra. Mhm. I hope we can correct this quick and go further. So C is 3. How the fuck is C is 3? I'm getting susu. Wait, is this wrong? No, that is, oh, that is czar. That notation is czar. That's not square. Why did I thought S? This is czar. That's not square. Fuck. We have answer now. So this being correct doesn't mean all of these will be correct, but because it's me coding, they will be surely wrong. This is wrong. Only that is wrong. This is right. This is right. This is right. So guys, can we hope that we can correct this thing, or should I? 1, 2, 3, 4, 5, 6, 7, 8, 9. But 1 in 9 plus 7 has 9 zeros, so this is smaller, so that's correct. So let's try to see again slowly. We have this is right, this is right. Everything here is right. This cannot be wrong. This is also right. I hope someone is there yet listening. Yet listening. Mhm. So let's just verify this one. Trying to add cases to NP. This has been taken. Then what happens is P of X changes to P of X cross X, or I'll just come in a minute. P of I. Otherwise, I hope people are there. It's too boring. By the way, I only practice on coder. I feel CF statements are too heavy with unnecessary. Solving some problems is what's needed. But you can CF has good kind of problems too. At coder problems, maybe a bit more brute force. But if you go to higher ratings in CF, they are all really good, I guess. Like that's what I wanted to show. But then I'm getting stuck on these shitty problems. We will solve this. I'll just come in 1 minute. If you guys can find any error, just tell me now. If you guys can see any error here. One thing I want to say to you people is, if you see these problems that I've solved so far, the logic has been simple, but implementation has been more, right? So, hello, I'm back. So, yeah, I mean, this is Su. So we should not think, even if I solve the problem, maybe I cannot implement it. Because if you actually solve the problem in practice, you will try your best to implement it. If you don't solve, if you see a tutorial, if you see someone else saying that, then you may not want to implement it. But if you actually solve the problem, Prismax or Susu, who is there, then you will surely implement it. In that way, you improve. How you improve your implementation skills is also that. Like when you solve some nice problem, you want to implement it, right? Like, so it can be funny. So, can I'm trying to say. So we have to find this error now. Maybe it is some overflow. Let me check if there are any overflows somewhere that I missed. And then only this matters because f of I into f of j is nothing but 2 power I 2 power j, b of I into b of j. 2 power I into 2 power j. We have long 2. But maybe also all of this will fall in long. Integer. All of this will fall in integer itself. This falls in integer itself. For all pairs. See, this seems wrong. That's the only error. Past. Hello. Who is there? Prismax or Susu? I think I look better when I do afternoon streams. When I do night streams, it doesn't look good at all. Damn, bro. You're the only reason like I'm able to continue this stream. Otherwise, I couldn't. And other good thing about these things is if you pass samples, most likely it will pass everything else. See? So yeah, we have solved this problem. Contest at night, right? That's your concern. 1920, just two problems is a lot for a 3 hour stream. So I'll try one more problem, 21. It can be solved very quickly, probably. I'll just try one more 21 and then we can stop maybe. Is that fine? Because we have a night contest. Maybe I'll come for post contest discussion or I wouldn't because I have some other things to do too. So we are solving one 2100 too because let's see how the problems may go. And then I may stop. I will next week maybe sometime I will do definitely 22, 23, 24, 25 because I want to show how the higher rating problems are not different in terms of logic. Not different or not weird as you see. So far we haven't used segment tree. So we are winning. No segment tree, no topics. See? No segment tree, no topics. Does this involve any topic? Now, you just have to be careful like to add up things disjointly. I'm doing that too in a nicer way. Keeping things zero, trying to split into cases, add them disjointly. So it's simple logic that we have to keep on trying to improve. See, when I say golden simple, what I mean is doing simple things is difficult. People cannot do simple things. People cannot read problem well. People cannot try a bit harder. People cannot try to make some code like this and see if it works. People cannot try after not getting for 2 hours or so, and then they want fast improvements. Okay, I'll try one more 2100 without talking much. This seems a bit good, but maybe I've tried that already. I don't know. Triangles also is looking good, but then G means it's some div 3 or something. I don't want to try. Uh, some div 3 problems are good, but some may not be. So I will quickly read the problem and then I'll decide. Is that fine? Is it fine now? Which problem are you doing? I'll give the link to here. So see, you guys can even practice reading problems. Try to practice reading problems. So what you have to do, Ankanayak, is try to sure. I will try to do this. I will try to read this problem. See, Ankanayak, what you have to do is you have to try to take so many problems, read them, understand them. It's all skill. Whatever you are mentioning now, it's just if you just sit there, take an hour, try and solve them, try to understand them, you will improve your skills just need practice, right? You will improve that skill. So you can try that. I have tried that. I have tried reading much difficult problems to just see if I will get scared of them or if I cannot even understand them or not. So let me read this problem very quick, and if I think it's a shitty problem, I'll skip. If I think it's a good problem, I'll solve. If I skip, I'll solve another 2100. So this is the problem. There is a regular polygon. So this is our third problem, just 2100. I'm not, for me all problems are same rating somehow. So let's try to solve this. There is a regular polygon of n sides. The vertices are in this indexed 1 to up to so on n. On each vertex I, pink soldiers have written. See, this seems like a good problem, right? This doesn't data structure, some topic, something that helps. Problem, and then only you can decide if you can solve it or not. Like you should not get scared at all. Pink soldiers have written a positive integer AI with this regular polygon. You will play a game defined as follows. So it's a game, it seems. Initially, the score is 0, then you perform the following operation any number of times to increase your score. So initial score 2, we will perform operation to increase our score. Select 3 different vertices, I, J, K, that you have chosen, not chosen. Draw the triangle formed by these 3 vertices. Then your score increases by AI times AJ times AJ. Okay, there is something. However, you cannot perform this operation. The triangle shares a positive common area with any of the triangles drawn previously. So this is not possible to make. So if you see the problem, if you see previous problems too, all the problems will get solved using what's given in the problem itself most of the time. They won't solve like big weird things, right? Everything will get solved based on what's asked in the problem itself. So even here, we must use like, okay, they should not overlap. And then we should be choosing. We should choose them in a nice way so that it's looking like some shitty DP. But yeah, we want to choose so that, see, there are constraints on how you can choose. We choose some triangles, means we group few three, we group few three, we group few three. And then after grouping few threes, among all possible variations, we want the maximum uh, number that we can get. Numbers can go till long because this 3 things will add up to 1e9 and then again n is there. So we may need long, but n cube itself says it's an n cube dp probably, because we are brute forcing. We have to brute force. See, dynamic programming, I'm again telling, is just a nicer way to brute force. Dynamic programming is brute force. Logically, what you do is brute force. So we try to cover all 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 the we are trying to cover all possibilities using dynamic programming, but we cannot have them intersecting is the rule. So if you choose this one, you cannot choose other things. So you have to capture the structure somehow. You have to capture the structure. So if you see in a cyclic order, they should be non-intersecting. You have to just capture the structure and then you're done. So what does non-intersecting means? So if you take 3 points into a group, you cannot, the remaining will become you cannot take the remaining, all the remaining 3 should come from one side itself. They cannot come from different sides. So we have to brute force the structure in a nicer way and then make a dp. Once you see the structure in a nicer way, you can probably write that as a dp. So what I'm trying to say here is ai, aj, ak, their values doesn't matter at all now. You need not think, okay, bigger value, smaller value, anything, because the problem obviously states you have to brute force everything. So this is a brute force problem. I wouldn't like this. I like ad hoc problems. uh Sorry, I thought of increasing my voice. So yeah, so I will not solve this problem. It involves, it's not difficult, but it involves few things because it's cyclic. I have to take care from linear to cyclic. I will try to just see how difficult the structure can be here. Okay, so how difficult can the structure be here? So let's first look at a bit linearly. Once we take 3 points, once we choose 3 points, it is getting splitted into many smaller rectangles, right? So once you choose 3 points, it's no longer linear anymore. Once you choose 3 points, it's not cyclic anymore. It's linear now, because once you choose 3 points, this side cannot have a vertex chosen from other side. So answer for that is, it's a linear from here to here. You want the maximum possible answer using these vertices. Again, it's a linear using these vertices. So what are all the different possible states here? The actual important states right after one vertex, it's like that. So what are all the important states? It's not cyclic anymore. It appears to be cyclic, but only after first operation it's not cyclic anymore. So what are states that we worry about is from this vertex to this vertex, from this vertex to this vertex, from this vertex to this vertex. So these are linear states. And once we have these linear states, now we can try to, so now once we have these linear states, so now let's think about the problem. So now we have a linear state. So now we have a linear. So this is not cyclic anymore, because if we find all linear, finally we can brute force on the initial triangle. Finally, we can brute force on initial triangle, and then we can make it like a cyclic one. Do you guys get what I mean? These are three portions. Triangle, right? So what I mean is, see, I don't like trying to. Implementations will be simple here too, because it's linear now. We have this three linear points. If you just maintain this array, we have its answer. From I to j, if you maintain this array, we can get its answer. So let's think about that now. Then, okay, let me solve this problem then, because even though but see, in terms of logic, how difficult G problem be. Right after this, values doesn't matter. You have to brute force dp, and right after one triangle, okay, now it's linear. Like just these things are being there. Don't give names to that. What's interval dp? Should I try to retrieve it from my memory now? Okay, what's interval dp? It's like once you take one triangle, it's split it into linear things. That's it, is what I was trying to say. So now what we have is we have to try to find a dp for a range. So now it's not cyclic. So given a range, given a range, okay, so now we have a range 0 1 up to so on n l, let's say. These are the cyclic points. We need answer for this range, right? We need answer for this range. Let's say L is not involved in any triangle. So starting from 0, we are fixing one vertex. Let's say try to fix one vertex and trying to see this total length L. Let's say n, 0 to n minus 1, where 0 has been fixed to some vertex. So now cyclic order is lost. So from 0 to n, we want the answer. Wait, we can even break that cycle. We need not even finally brute force that, because let's say in an optimal structure, this vertex has been chosen. That itself breaks the cycle immediately, because now you can break that immediately, because now this edge will not come important to anything. That can be broken immediately, and then it's like non-cyclic again. It's again non-cyclic. So it's always it's always non-cyclic. So now it's linear. We have n minus 1 things. So let's just see for 1 up to so on I. If I is not involved at all, so dp of I is just dp of I minus 1, right? If I is being involved now, so it's a linear. I is being involved. What are the previous two things that are there? What are previous two things that are there? Can we brute force them? Uh, okay, let's say you're choosing x and y here. So now the answer would be I, y, x are coming together, right? I, y, x are coming together, right? Hello? Is anyone there? Bro, it's not geometry though. It's just how do you group things? Is Prismax there? It's not geometry though, no. See, now they are linear. Should I draw now? Because they are linear. So now they are linear, right? You can imagine them as like 0 here, 1 here, 2 here, 3 here, 4 here, 5 here, like a big polygon. 0, 1, 2, 3, 4, 5. A big polygon is almost linear. If n tends to infinity, it's like it looks like it's, and then if you look at smaller part, it looks like infinite. It looks like small. So now what I'm trying to say is, see, uh, so what I'm trying to say is, so if I is not involved, we have this. If I is involved, from 0 to the previous one, if I is involved, it may have y and x. And then the answer for that is dp of 0 x minus 1 plus dp of starting at x. At least the length is being reduced. X plus 1 to, let me keep it 0 to x plus 1 to. dp of x plus 1 to y minus 1 plus dp of y plus 1 to I minus 1. Because the triangle goes from I to y to x. This is the triangle. So we have from 0 to x minus 1 few things, from x to y few things, from y to here few things too. Can we simplify this dp? Because 0 to I, this itself can occur n square times, right? This itself can occur n square times, and for each of that n square state, we cannot be doing additional n square things. We cannot do n power 4. But still, there can be things we can surely do here, because we can make our dp better. In what way? Like, suppose, let's say if 0 is not involved and y is not involved, if both of them are not involved in anything, then we can just directly write this thing, right? So if I is not involved, I wrote this. If 0 is not involved, I can write this, because even that's a smaller thing. That's smaller, it's smaller than 0 to I. 1 to I is smaller than 0 to I. So now if both of them are involved, from here we have something, but the triangle can be a bit complicated to know. But still, I don't think, I thought it will become too simple, but it's not becoming too simple. So let me go back to some nicer problem. This doesn't have any logic, right? Linear part in the sense, once you see if you see one triangle, it's not cyclic anymore. From here to here, it's all linear. No. Linear means it doesn't circle back now. If you put one triangle, because they should not intersect, it's not cyclic anymore. No. Yeah, I'm going to some other problem, because like I wanna see what am I doing is actually beneficial for our stream, because I'm trying to show ideas of more problems while not implementing some shitty solutions. This seems fine, but it's from something else. So make it equal. Maybe it can be a good problem, but I'm not sure about these contests. Maybe it's a bit more difficult problem too. Uh, so, but I have commented about the problem, right? It won't be too difficult. You will somehow see the structure. All DP problems are trying to understand the structure, trying to put the structure into some equations or something like that. I mean, trying to brute force the structure in a nicer way. You group things so that you can brute force them well. So this is simple. The problem is direct. Like the previous one is direct. It's just telling it's direct. This seems nice. So let me try this then. Even though it's whatever this is, I'll try it. You're given an array A of length n. The elements of the array are numbered from 1 to n. I'm not flexing. I'm tired. You can perform the following operation any number of times. Choose an index I from 1 to n, decrease ai by 2, and increase ai, the next one, by 1. So we reduce this by 2 and increase this by 1. See, if you guys stay, there will be nice problems. In higher rating problems, there will be very nice problems, like just after finding something, everything is done. Rather than finding some shitty things, rather than doing some shitty things. So you can enjoy solving more if you try harder problems, is what I was again trying to say. After you perform, all elements of the array should be non-negative equal integers. See, this seems a bit nice, right? It will ask us to calculate that. This seems a bit nice. So minimum number of operations. So if they are asking minimum number of operations, I like it more, because if proofs are simple, implementations are simple, solutions are simple. Sorry, order is wrong. But yeah, then this gives us more hints that okay, there is something there to work on the problem. You guys get what I mean? Oh, it's all my legs are hurting. I went to work out a little bit, leg workout, and all of them are hurting from 2 days. Uh, you're given. See, this is a good problem. Let's try to think about this problem. See, if you solve some shitty problem at 1700 or 1400 that involves k less than or equals to 10, brute force it multiple times, that's bad, right? But see, this problem, this seems like a good problem, right? You have to find a way to make them non-negative equal, and then you have to find minimum number of operations to see. If you believe in golden rules, this is a good problem now, right? So try and Prismix are the people that are there, right? So let's try to do this problem. Yep, we'll try to do the problem. So whenever there is an operation, we have to look carefully at that operation. You get what I mean? So what does that operation do? What does that operation do? OP? We cannot make anything as negative. They all should be greater than or equals to 0. And we are decreasing AI by 2, increasing AI by 1. Some element by 2 and increase cyclic array. Next one by 1. So if you see what all we can do, operation on operation, what can we say? One operation reduces total sum by 1. This we can say immediately, right? Those are my golden rules that I try to. I wrote a blog too on that. Like, solutions are simple, proofs are simple, implementations are simple. So if you see PrismX, if you see my previous streams, I tried stressing on these points that we can use proofs are simple to our advantage. We can use this to our advantage. It's not even knowing thing. We can use this to our advantage, and we can think, okay, if there is a simple proof to it, what would be the solution? We can think in that way too, and that helps us too. Maybe for this problem, I can use that because this is a bit nicer problem, right? There are some operations, and I need not think too hard too, because it's a 21 is too less, right? So let's try to think, see this one. And we should, one immediate small observation is, this means it's good to look at adjacent elements, how their difference changes, right? So if you look at AI, next minus current in the same order, after an operation, next minus cur, let's look at this array. Let's call it B of I. Okay. What happens to this array? Think about that. B of prev, B of for B, prev reduces by 2 because next has increased. Sorry, next has reduced. This has not changed. This has increased. So prev will reduce by 2. Cur, next has increased by 1. this has decreased by 2. So what happens to next minus cur? I'm trying to see this because finally this should be 0, right? If everything are equal, this should be 0 finally. Is anyone's here? Go to my profile on Code Forces. If you're smart, I think you can do that. And then go to blog entries. And then upload this. Upload this. Okay. So, do you guys get what I mean? Like, let's assume like prev cur next. So, an operation, and then we have two arrays to A, B. When an operation, what an operation does is to the array, it reduces minus 2 and then it adds plus 1 here. I'm just trying to say how you look at this array B, which is nothing but this minus this. So this will become plus 2. And then if you look at this minus this, it will become plus 3. And then if you look at uh, next for this, the next one minus this, it will become minus 1. So next minus this, right? So this is minus 2. Sorry. This minus this. This hasn't changed. So it's like minus 2 plus 3 minus 1 because the differences array, cyclic differences array, it should not change, right? I mean, its summation should be 0, right? Because it's cyclic, everything will eventually cancel out. So the operations effect also should be 0 here in this array. I'm just trying to say this for no reason because finally this should become equal, right? This should become all 0. That's why I'm trying to say this. There's no reason. It's not a technique. It's a technique. It's an actual technique, but it is what it is. Hello, Prismax. Do you get till here? Like it's fine, right? So far. Any new people? Can you people try to like the video so that it reaches more people and maybe 99% people or guys that watch my videos. That's bad. Cur, that shows how misogynist programmers can be, right? These people can do for loop and small things, and then again they want to act like they're smarter than us. They can name themselves as smart or something like woman smart, woman minus smart, but they can never be smart other than they are smart. Just joking. So now if you see this, we want to make this thing as the b of I. We want to make b of I as 0 finally. We can see the normal operation too. Something will become minus 2, but the next thing will become plus 1, right? Or we can see any transformed 1 2 sometimes if it helps, because because we can try to maybe play on this 2 and 1, like 2 times next minus this one will not change that much, but then the next things will change. But I think it's not that beneficial, so let's just try to solve this one. So one thing, can we make all of them equal is one question. Can we make everything 0 using these operations? Can we make everything 0 is one thing, right? Or let's look at the normal thing itself. Okay, let's look at the normal thing itself. It's being obvious. Few things are obvious. If you know final array, that fixes number of operations too, because of this point. So in another way, we want the minimum thing that we can keep, right? So it's not that difficult. I tried seeing these things because sometimes when we look like this, everything will become so simple, and then we can immediately do that. But this problem is not that difficult problem, I guess. So this also means what's the maximum final element that you can achieve. See, they want this may be easier problem if they have stated this instead of minimum number of operations. If they have just stated this, it may be a more easier problem. That may be a bit more easier problem because now we can just focus on like what's the maximum value that we can achieve finally so that everything is equal, right? So that everything is equal. So let's think about this too. Okay, because this is fine, right? That maximum element also defines the minimum number of operations. So now if you look at, we can even look at these things that minus 2 doesn't change parity. Uh, Next plus 1 changes parity of only one element. So one OP changes parity of only one element, right? And it's also obvious. Few things are also obvious that uh, if you know final value, okay, what all will change? What all will affect the value of a of I? Operations on it and operations on previous things, right? So let's look at that array. Okay, let's say we have this array op of n, number of operations that have been applied on op of I. Okay, let's say we have this array. This is also seems like a very good uh, way to work on the problem, right? See, you guys has to find the ways to work, find some ways to work on the problem. This seems a good way to work on the problem, right? Let's say these are the operations, that final operations. Op of I is an array that says I haven't kept my work thing on LinkedIn because it will tell everyone that, oh, this guy is working here, congratulate him or something like that. That's why I haven't kept there at all anything. I'm working at Apple currently. It's been 1 year. I have one year work experience at Apple, and now it's this next month. VP rank to here. Those are not that great. This is a good. I think it's coming top 35, but I haven't kept because it says everyone like this is doing that. But I also get like people approaching me for jobs, thinking like I'm just graduated or something like that. I don't know. So I just didn't keep it for no reason. Like there's no use, I guess, right? I have my work. I'm an YouTuber, professional YouTuber. As you guys can see, I'm doing series, solving each problem in it. So if you have this, we can work on the problem, right? We can work on the problem. If you have this OP of I, what's the final value? A of I minus twice of OP of I plus OP of I minus 1, right? This is the final value, right? Is this fine in cyclic way? Even there, I hope Prismax is there because Manhattan pairs question is a nice problem, I think, because mm, see, if you see independently, it's I hope it's fine now. So see, in that Manhattan pairs question, final answer is independent x maximum and independent y maximum is possible. Sure, thanks. I won't say that. Yeah, I'll tell it later. That see, there are so many ways to approach it. So you can try to think of yourself. It's not like magical. Again, there are so many ways. So let's try to solve this problem quickly. Let's try to think about it a bit intuitively too. Okay. 1 minute. So we have these things. A of I minus this. Finally, all these things should be equal, right? Finally, all these things should be equal. And what's that value is what we are having, right? So we can try to think, is that value unique? Maybe it is unique sometimes, maybe it's impossible times at times, but maybe it may be unique too, right? Because if you can use some logic and maybe say that value is unique, you cannot have multiple such values, even then we have done something. Can To say it's unique, let's try to see them as equations. Okay, now we have how many equations? All these are equal, which is like n minus 1 equations, right? We have op of I as n variables. See, this is not like linear programming technique or anything, but whenever we can use something, we can try to use such logic to help us. That's not needed to solve the problem, but maybe to help us understand things. So it's like we have this itself makes like we have like n minus 1 equations, right? And also op of I, this thing should be greater than or equals to 0, but yeah, we have this n minus 1 equations here. Or is it more equations? We have first thing equals to second thing, first thing equals to third thing, first thing equals to fourth thing. Yeah, n minus 1 equations and n variables. See, we can even see this thing. You know what we can see? If you see b of I equals to 2 times op of I minus op of I minus 1. Okay, if you try to see this, then this will just be like a of I minus b of I, right? And once you have once you have but then we don't know the restriction on this, like op of I should be greater than or equal to 0. I'm just telling we can sometimes do such conversions, like, and then once we have b of I, can we get op of I back is the question. If you have b of I, and if you know op of 0, just op of 0 and b of I, you can get op of everything back, right? Because you can get everything back. So just looking at this is also fine. But yeah, let's try to solve this problem somehow. It shouldn't be very difficult, like I'm trying to do it, but see, you have to think here for problem C, right? What is greedily the optimal thing to do? Greedy is one thing, but you have to think, should I actually do greedy? What's the freedom you have here? What's the freedom you have? And then, in a linear case itself, it's not matching the first and the last thing, but matching the first half to the last half. Do you get what I mean now, Aditya, Bharatiya? Because if you see the expression x1 minus x2 plus x3 minus x4 up to so on, that expression, finally, you can drop some time. Can you say me that? I'm trying to show the proof. You can drop the modulo, right? Then what do you see? You see half elements minus half elements. What's the optimal way to achieve it? What's the optimal way to achieve it? You want this to be the first half, and the next half to be the next half. And if you pair them, the answer will not change again, because this will again take positive and this will again take negative. It's again necessary and sufficient kind of logic. You try to see this is proof too, but if you question independent case itself, that says it's not the freedom you have here is first half getting matched to next half, and now the C is an extension. Can you try to match first half to the next half and also parallelly doing that along y direction? That's it. That doesn't seem too much unapproachable, right? Just seeing independently one thing. What's the restriction here? How's that? I wanted to do a video explaining problem C, but then I had something else. That's why I haven't. I anyway posted that one, right? So I haven't. This will not get views. 4 hour. I will just stop after this. I think it's too long. I will try to solve this. So if we reduce, let's think about it. Let's think about the problem a bit. So even we have this thing. So if finally they are becoming equal, let's say finally for some value z they have become equal. Okay, uh, let's say for some z they can be equal. These are just equations, right? Equals to z. Let's say for some z they can be equal, like we have an op such that for this op we can have z equal. So now so now we can try this problem. It's likely a good problem. Just stay sometime. I think I'll stop after this. See, the thing is, once you don't think mathematically, but once you think, okay, what's the structure, then you can try to prove it immediately, because proofs will be mostly simple. Yeah, we can try to solve this. We will solve this somehow. I didn't directly come like okay, half for positive, half for negative, and then I thought, can we prove this? Then we can see that. That's why solutions, you have to believe that solutions and proofs are simple. So let's try to think about this one too. I'm not getting anything to do this. I was just trying to use some logic, like if z is unique or if it can be found in some way. Let's say if all of them are equal, okay. Can we do some operations and then again make all of them as equal? For that, seeing this itself makes sense again. So we do -2 to something, +3 to something, -1 to something. 3 things are getting changed. This is even worse. 3 things are getting changed. So we have to output -1 when it's impossible to have some z where all these equations are consistent. Like you get OP of I greater than or equals to 0 because you can only do positive number of operations, and then it's impossible to get these things being greater than or equals to 0. Can we try to think something else, like let's try to look at minimum and maximum or something like that. Like if you look at minimum and reduce it once, like increase the minimum and then the previous one reduce that a bit. See, also in all minimization problems, if we are proving, we will have lower bounds. We find a lower bound, and then that lower bound, if it is good enough, that's the optimal thing, because lower bound says your value should be greater than this much, and then you say I found that itself, so you say its proof is done. Even for the problem of Manhattan pairs, Aditya, if you're here, what can be an upper bound for the problem? An upper bound can be independent x value plus independent y max value. That can be surely an upper bound, right? And if you find that upper bound in some way, the problem is done. Proof is done. So even if you use proofs are simple, you can approach that in that way. Okay, it seems so complicated. I'm not able to find a DP greedy for 2D. Uh, but still, if there is a simple solution, how what can it be? Maybe I'll look at the optimal value. What can the optimal value be? Okay, optimal value. Let's say the optimal value is independent optimal x plus independent optimal y. That's definitely an upper bound. And then you will see if it is a good enough upper bound. See that finding upper bounds is always good. Even here we can try to find lower bound. Is there a lower bound? A minimum can increase a bit, reducing the previous things. It can again increase, and so on. Yeah, but I don't see much. A minimum is a lower bound, but I don't think we can. A minimum is not a minimum. You cannot make every. Wait a minute. What is? You want to maximize the value, right? Yeah, you want to maximize the value. So a minimum is not an upper bound to here. Max value is an up. I'm complicating things. Let's just leave that. Think about this problem. Someone help me. It looks a bit difficult. I don't think even it's even like 2100. See, so we have to solve this problem. Someone help me. I guess like few things increasing, this thing will decrease by 2. And if something is too big, we have to apply so many operations on that to reduce it. Also, that is true. Where is that problem? Here it is. Damn, it has more solves too. So let's try to see. Let's try to think for some time again. I'll write one useless point. So these are n minus 1 equations. If you add z, these are n equations. If we add z, these are n equations, right? And then we have to find maximum such z, for which also OP of I greater than or equals to 0. Let's try to think again. Let's look at parity ones, okay? Because the parity point also, let's look at that. Right. So if final value is, let's say, we must apply. So it changes only one element's parity, right? So that means, yeah, because it changes only one, it doesn't put any restrictions. So it doesn't put any restrictions means like, because based on this parity, we know this thing should be applied uh, odd number of times or even number of times. That can be known. For OP of I, we can know that thing. Like if this is applied even number of times, we know okay, this should be applied odd number of times, because that can be told about OP of I based on parity. Because if OP of I has been applied these number of times, that means the next thing has been parity has been changed that much, and based on that you can know something else as parity too, because OP of based on the next element's parity we can know OP of I's parity. That's one thing we can say, right? We reduce 1 by twice and then we increase 1 by 1. We can say that, like, based on next thing's priority, this thing will get fixed. But let's see, this is already 1 2 1 3 2 is impossible. Increase this will reduce by 2 1. Let's see minimum 2 a bit, because damn, this seems difficult somehow. But still we can try. Yeah, it's cyclic. I have, otherwise it would have been, that's what I'm thinking, it's cyclic only. That's why I have any equations, right? Ah, it is cyclic. Do we have any equations? No, I know it's cyclic. What I meant was, if you have n things equal, that's n minus 1 equations, right? Is what I meant. Yeah, I took it as cyclic. Yeah, but what lower bound can we give to minimum number of operations? Like, at least these many operations should be done. We have to give some upper bound to the value also, I guess. Like, what value can be possible? So let's try to think slowly. You guys can take time, try to think something that would work. I will also try to think for some time, maybe. We will end after this solution, this problem, but let's try to think. See, we can solve this somehow, because we can solve that. So, if we have final value z, let's say final value is z, what do we have here? 2 times op of I minus op of I minus 1 equals to a of I minus z, right? This is what we have, right? If we add all of these things, we get that total number of operations equals to sum of a minus z times n. Because if you add all of these things, one will get cancelled, one will remain, and we'll get this thing that we already know. That's not any useful thing. So we have these n equations. Means with these n equations, can we to solve everything? Let's say if you fix op of 0 2, so z has been fixed. Then can we have everything again? is another question we can think of. Then what would be all the other values? So the question is, for what value of z we can have solutions to this OP such that they are all greater than or equals to 0, right? And we want such maximum value of z. Z can be greater than a of I2 for something, because z can increase whatever. Z not Z can increase, an element can increase. So if we fix one value, using that we know next one, and then using that we will know next one, and then using that we will know next one, next one, next one, up to so on, right? Maybe it's a difficult one, bro. We cannot do anything sometimes. Or maybe it's an easier one and I'm just. Let's try to see why it's impossible here. 132. Whatever. But yeah, we have spent already, so let's still try somehow. If we can solve it, maybe we can learn it. We can try to see why we haven't solved before so quicker. We can think those things, right? And then you can get the next one, and then you can get the next one. You can get everything, right? But then finally, you will notice that. Finally, you will notice that. Uh, when you get everything, you will get everything using n minus 1 equations itself. But then that should satisfy uh, the final equation too. For that final equation, you can just use this thing. Sum equals to sum of a minus z times n. We can use this thing. So using all these things, we can have an equation for OP of I in terms of C comma Z, and we can have an equation finally for C2. C equals to Z. For equation some C times equals to n times Z. We can even have that equation finally. And once we have all of that equations, you guys see what I mean? So we are fixing OP of 0. And then we will even be having C by 2 things. C by 2, C by 2, C by 4, C by 8, up to so on. But let's say it's fine. Let's say it's fine. Still, it's like 1 by 2, 1 by 2, up to so on, right? Maybe it's fine. They all should cancel out too properly. If OP of 0 is C, we have an equation for each of them in that. All of these things. From this C, we can substitute. I should be joking. From this C, we know C in terms of Z. Now, we can substitute that here. And then we have OP of I greater than or equals to 0, right? Using that, we can get the maximum Z. How's that? For which maximum Z comma C. But this seems too complex. This should not be the answer. Talking too much. No screen means? I'll quit it then. Should I stop here? Maybe we all have time. You guys have night contest, right? Did the video screen got stopped? So one thing I tried telling previously was, if you fix c comma z, c is like op of 0 and z is like the final value, we can have all op of i's using these things, right? All op of i's we can have in terms of some constants and z. And once we have that thing, uh, we can apply op of a greater than or equals to 0 as the conditions for c and z, and then we have an equation too for c and z. So this equation for c and z will restrict both c and z in some way, and using this op of I greater than or equals to 0, we can find the maximum z or the minimum c, something like that. Hello? Yeah, I will do that one. I will surely not see solution. Yeah, we should do that. When something is going too complex, we have to do that. Here I'm not uh, using it to, I know this is definitely not solution, but I'm just thinking if that can help us in some way, is what I was just trying to see here. Like maybe if it can help us in some way, because I got stuck in this thing a bit. See, this thing says something about the problem. Like if we fix both c and z, we have op of I greater than or equals to 0. Like it's like many constraints. It's like we have few constraints in terms of c and z, and then we have uh, it's like a linear equation, right? So and then we have one linear equation, and we have few constraints, and then we want maximum z. So we can know what should the c be. So it's like some constraints and then an equation, right? So this equation, and then we have some constraints. Maybe we can use that linear algebra kind of thing a bit and try to solve the problem in that way. That seems too much, but if we try to do that, all of these things, all of these equations will form. So op of I has many equations in terms of like c and z. I don't know what those equations are to, but that at least says something about the problem structure, right? We have many equations and then we have a line, so we want uh, maximum z now, maximum z. So whatever the line was here, uh, we want now like maximum z. So it just says something. So this line will intersect with so maximum z. So it's just a line. As we go to maximum z, it will intersect with some constraint of uh, op of I greater than or equals to 0. So at optimal value, some constraint of OP of I will be 0. Damn, is this true? What question are you talking about? The same one. Even I am trying a lot, right? See, guys, so you guys can see how you guys give up and how I don't give up. It's been an year that I graduated, and I'm still giving contests after even having a job, and I'm not even trying, thinking that okay, I'll get some other job, nicer job, if I become grandmaster or something like that, because grandmaster is unnecessary. So that shows. See, doing some sheet every single day, doing some sheet for 30 days uh, would not make you learn as much as if you have actually tried something for 1 hour, 3 hours, 4 hours continuously. You may think it's time waste. You may think you may not learn anything, but then maybe you improve while doing such a thing. And then if you learn something out of it, maybe you improve only at that time. Maybe your thinking you might have gone a bit more deeper because you are in that thing. And if you never do such a thing, you cannot do such difficult things. Like it can be for any competitive exam or for this or anything. So what do you mean? You have thought a lot. So let's think about this now. So it's just a 2D plane, C and Z, and then we have a line. We have many other lines restricting our line, which are OP of I greater than or equals to 0. So because these are our constraints, as z increases, it will touch one line, one constraint finally, right? So this is actually giving me some insight. Not even insight, it's giving me a fact. So when it touches that line, what does that line mean? OP of some I is 0 at max. So this is a fact. But how does that help though? So OP of something must be 0 at optimal. Can we brute force that? So at least I was able to say this point using this linear algebra logic, right? Do you guys know that? You guys saw that, right? Like just using that linear algebra logic. So the constraints we have here were like just this OP of I being greater than or equals to 0, and then I was able to represent everything, uh, all OP of I in terms of C and Z, and then I just saw them as lines. And then the final one line we have is this is other constraint we have. These are all the equations we have, and if you have a solution that satisfies all these constraints, what is n here? N is not that small, it's big only, yeah, but still. So that says at least some OP of I is 0. One OP of I is 0 here at least. So let's see this too. Hello, is there someone here? Bro, even I was stuck, bro. Even I was stuck from pupil to specialist. Somehow we had to try harder problems. We had to. Uh, I was stuck here, pupil to specialist for quite much time, and then see this stuck. Sorry, master for how many years? Like 2 3 years, and I'm still trying for grandmaster. Right? You would have given up right here, I think. Or if you even if you have began here, so just keep somehow try to figure out things now. So guys, whoever are following this, at least we got this thing, OP of I equals 0. This makes sense, right? See, in terms of C and Z, those are just linear equations telling less than or equals 0, less than or equals less than or equals 0. And then we have a line. And if C and Z satisfy all these constraints, then we have all OP of i's, we have made everything to Z if it satisfies all these constraints, because n equations will handle out. So that just says that just says something. So now let's try to look at it again. So if you fix, so that means for optimal Z, we have something being zero, some OP of I is zero, because one constraint will be tight, right? The tight constraint is zero. So now if you look at it again, if this tight constraint is zero, let's just make OP of I as C, right? So let's make that as zero. Let's make that I thing as zero. Okay. Instead of because OP of zero is C, we took that initially. So now because it's cyclic, right? We can start anywhere. So now let's say we are starting at this point. Okay. Let's say we are starting at this point. So if we start at that point, we can again write everything in terms of just Z, and then we have this equation. But we don't know what that is, right? That's the tricky part. Yeah, we don't know what that is. Because some A of I will, it's not symmetric with respect to A of I. We don't know what that is. So in O of n, in some way, we can, if you fix I, we can have n possible values of Z using all these equations thing. Because if we fix OP of I as zero, one thing as zero, you can get everything in terms of A of I minus Z and so on, right? Then you can finally have this thing too, that sum of all OP of I is equals to Z times n, which is nothing but adding all these equations itself. And then you can have that one too. So at least we have now n possibilities for Z, for max Z. Among them, one satisfies for one Z will satisfy all the equations. All the equations of OP of I greater than or equals to zero, and then we are done. So in O of n square, maybe we can do it. Yeah, I'll just stop it maybe right now then. It's too much, right? Maybe I'll think about it later. Some problems we cannot solve. That doesn't mean we cannot solve harder ones, because I have recently itself solved one 3500 when trying something. Not too recent, but uh, I'll just flex that and then we can leave. See, not being able to solve some problem doesn't mean anything at all, because we can solve much harder ones too. This doesn't work. So just leave it. So that's what, right? If you keep trying, maybe you will get tired after 3 hours, after 4 hours, and so on. That's it. You improve slowly, I guess, in everything. But you have to try. If you every time if you stop after 1 hour by keeping a timer, you cannot go for 4 hours, right? If you sometimes exceed 1 hour, if you sometimes exceed 2 hours, maybe then you can go for there. But if is having OP of I as zero in optimal, but this is a very weird point, right? That something is not at all having an operation on that at all is what we are able to say by the constraint that uh, by the constraint that OP of I greater than or equals to zero. From that, I was able to say OP of I equals to zero. Some OP of I equals to zero. If this OP of I is zero, we know the next one, and then we know the next one, and then we know the next one, and then we know everything. Right? If this OP of I is zero, means we know the next one. Like that must be this thing. Maybe we have more constraints too. If you have more constraints like the parity constraints, maybe then we cannot have OP of I is zero for optimal. Should be a bit careful too. Yeah, okay then bye. I'm ending it. It's too much. I'm ending it's too long, right? People cannot watch this. So I'm ending it. Bye. Bye, Prismax. You can try to join my group. You can find the link somewhere. There is a WhatsApp group. You can find that link in my posts. Bye everyone. Ending it.